pronounce your name incorrectly most of the time.
Yeah, it's originally a Polish name with a German spelling. So this is why essentially nobody can pronounce it correctly. Lowest bar.
सही है अभी तक तो हो गया और वहाँ पे एक माइक रखवा देना हैंड माइक पोलर माइक से जो स्पीच देंगे
ज़्यादातर यही है क्लियर है ना
हेलो चेक चेक हेलो चेक माइक चेक हेलो हेलो चेक माइक चेक 1 2 3 चेक
Distributed Systems at Imperial College London, where he leads the large-scale data and systems group. His research work focuses on the design and engineering of scalable, reliable, and secure data-intensive systems with a particular interest in machine learning, data management, cloud computing, and security. Currently, he serves as program committee co-chair of the ACM European Conference on Computer Systems, a general co-chair for International Conference on Very Large Databases. I was director of research in Department of Computing, served as the chair. It looks like he served as many chairs. So thank you very much for joining us. And you have about, no, you have half an hour, right? And then we'll have another presentation, which is also half an hour, then discussion at the end of it. Thank you.
Yes, thank you very much for the kind introduction. It's a pleasure to be here. Unfortunately, need some more AV support because I don't know how to switch over back to my laptop now. So, sorry, could you help switching over back to my laptop? Yeah, I mean, it worked previously.
No, because I gave
I
them.
don't know what to press there.
No. So is this your laptop?
Yeah.
Oh, okay.
Yeah. Well, I just need to switch over so that I can see.
It's already showing but
No. That you're showing.
Oh wait, no, now it's working. Great. It's all good.
just a second
Yeah, it's fine. Okay. Good. Yeah. All right. So it seems to be all working. So yeah, apologies for that. So what I would like to talk about today is the evolution of AI at scale. So I would sort of give my thoughts on how both hardware and software has evolved in enabling modern AI systems, and I'll also talk about some of the challenges that have been a consequence of what has happened in this space. So when we look at the progress that we've experienced in AI, it's really something that is unmistakable in terms of the impact that AI models had across different application areas. So there are all of those problems in computer science, such as image classification, natural language understanding, reading comprehension, that used to be really hard problems, right? So we had essentially PhD students sort of working on those problems, making incremental progress. Then AI models came along and completely changed everything. And this is what you can see here on this slide. So you can see the performance of AI models on those tasks in terms of standardized benchmarks compared to a human baseline. And you can see that over the last decade, for a lot of those problems, AI models now beat a human baseline. They've become more effective than what humans can do solving those problems. So kind of a good example of that type of progress is if you look at the evolution of conversational AI agents. So if you take a simple prompt, such as explain the major accomplishments of Theodore Roosevelt's presidency, and you had typed this into the GPT-2 model back in February 2019, this is the response that you would have received, right? It would have told you, but the only things that will change with a president who knows how to operate a business is his understanding of the American system of government. None of this makes sense. It's English, but it's complete gibberish, right? It's not answering the question at all. So then you only look a bit more than a year later when GPT-3 was released. This is the answer that you would have then received in June 2020. So then it says, Theodore Roosevelt's presidency was marked by a number of accomplishments. He's credited with leading the United States out of the Great Depression into World War II. So now this is much more credible. Unfortunately, I think I'm okay with this one. Unfortunately, it's made up, right? So he wasn't the president that led the United States out of the Great Depression, right? So it was clearly hallucinating the answer. Then we look at ChatGPT in November 2022, when it was actually released. This is the answer that we get now, right? And this actually looks quite convincing. It's sort of nicely structured around sort of areas of accomplishment of Theodore Roosevelt's presidency. Now you have to look very carefully to spot the mistake. So actually, ChatGPT then claimed that Theodore Roosevelt founded the Grand Canyon National Park. Well, that wasn't him. But everything else is correct, right? So again, we're looking at a couple of years of technological progress from something that sort of was pretty much useless to something that could be used as an effective tool. So the third example that I have is the generation of synthetic faces. So this has been an old problem in computer graphics to generate photorealistic faces. So humans are really good at recognizing faces and sort of noticing imperfections in a synthetic face. So again, when we look at the state of the art only 10 years ago, you can see this on the left-hand side here, we could only generate those very low resolution, simple faces. Now we look at what is possible today. You can see that we can now create photorealistic faces that essentially a human would not be able to distinguish from a photograph. So it's another example of something that is now a solved problem. So where does all of this came from? So when we look at the theory behind neural networks, well, those concepts were known for a really long time, right? So when we look at, for example, the first computational model of a neural network, so for example, the perceptron, that was actually developed back in the 50s, right? So we know the maths and the theory behind all of those techniques for a really long time. Also, when we look at the first applications of neural networks to solve problems, this is also something that has been done a long time ago. So back in the late 50s, a neural network could be used to implement echo elimination in phone lines, right? So an early application of a neural network. When we look at computer vision applications using neural networks, again, this is something that we've experimented with back in the 80s, right? So there was this project at CMU at the time of implementing, well, autonomous driving using where the computer vision system would use a simple neural network to essentially distinguish between the road surface and its surroundings. So all of this existed for a really long time, but we only saw this recent explosion in terms of impact and applicability over the last couple of years. So why is that? Well, it is because of scale, right? So the one ingredient that has really changed quite significantly is the size of the neural networks that we have, the number of parameters that they use. And this is what you can see on this chart here. So there's time on the x-axis, and on the y-axis, it's the number of parameters in neural network models, and the y-axis is logarithmic, right? So you can essentially see here the exponential growth that we've been witnessing over the past decade of neural network models and large language models. So the different colored dots sort of show the origin of those models. So the blue dots towards the left are, the blue dots towards the left are models that came out of academia. So this is sort of where things started. And when you now look towards the right, where we sort of really see that exponential growth, a lot of those models then came out of industry or out of collaborations between academia and industry. All right, so we managed to now cross the billion parameter threshold, and so we're now sort of operating at creating models that have sort of tens to hundreds of billions of parameters, and we can even create trillion parameter models, right? So this is sort of quite mind-boggling when you compare this where the space really started out in terms of simple neural networks that people created. So this requirement to support scale has led to this huge investment in data center infrastructure that we've seen across the industry, right? So there are all of those different announcements by large technology companies in terms of the investment that they're committing to create new data center capacity specifically to support the training and inference using large language models. And the numbers are really mind-boggling, right? So this is the quarterly infrastructure spending by Amazon, Alphabet, Microsoft, and Meta. So in a single quarter, companies are committing to spend $100 billion simply on their infrastructure growth, right? So again, like this is something that is unprecedented. We haven't seen anything like this before. So how is AI done at scale, right? So we are creating all of this infrastructure. So how does it actually enable these types of applications and these types of advances? Well, so one critical ingredient is hardware acceleration, right? So GPUs are one of the dominant type of hardware that we use here to accelerate the computation that is needed to use, for example, large language models. And so here one of the drivers have been Moore's law, right? So Moore's law is this observation that the number of transistors on a chip sort of roughly doubles every 2 years. And it sort of has been doing this simply due to technological advances, right? GPUs were one of the technologies that have really benefited from this, and therefore each new GPU generation that is being released is significantly more powerful simply because of this progress. So it was almost a fortunate coincidence that GPUs ended up being hardware devices that work really well when you want to accelerate AI applications, in particular large language models. So when you have a particular large language model, such as, for example, one that is following the popular transformer architecture, you can express the training and inference computation essentially as linear algebra operations, right? So that's sort of how we think about the algorithms that we execute. And it turns out that those you can then express as a data flow graph with particular operations, such as matrix multiplications. And these are exactly the kinds of operations that GPUs are really good at accelerating, right? So they can take, for example, two very large matrices and they can multiply them, exploiting the parallelism that is then offered by the hardware. And this is sort of why GPUs are uniquely suited to accelerating these kinds of workloads. So now that we have those GPUs, we can now build larger infrastructure. And you would sort of initially think that, well, so surely what must have happened, people built supercomputers out of that. And that's sort of partially true. So obviously, if you sort of follow the supercomputing model, you can achieve very good performance. It's also going to cost you quite a bit. So instead, what we've seen is that we've seen rather that many organizations essentially built up large GPU clusters, right? So they buy a lot of servers with GPUs, they interconnect them using sort of regular commodity networking technologies, and they fill their data center with that kind of infrastructure, right? And that's sort of this scale-out model is sort of the dominant way how we can create large infrastructure with GPUs. Okay, so now that we have essentially hundreds of thousands of GPUs in a data center, well, how do we actually harness them and use them, for example, to train a deep neural network model? And again, like the techniques that we use here are fairly simple and they've been known for a long time, right? So one example is that, well, if you have one GPU, you can train a neural network model using sort of standard algorithms such as stochastic gradient descent, right? Which sort of solves an optimization problem that it slowly refines the model parameters based on a set of training data, essentially trying to minimize the error within that model. Again, like those algorithms were known for a long time, so you can execute this efficiently on a single GPU. So what about if you have not one GPU, you have many GPUs in your data center? Well, so what we do is we simply take the training data and we subdivide the training data into data shards, and then each GPU is going to train its own copy of that neural network model on a slightly different subset of the data, right? So you can now see how we are essentially linearly speeding up the training computation because each GPU now needs to cover less of the training data, right? So that gives you that linear speed up. So if this was everything that we would be doing, well, one problem is that each GPU is training a separate model, so essentially the models would diverge, right? They would be different because they were trained on different subsets of the training data. So there's something else that we need to do. We need to synchronize across those GPUs. And conceptually, the way to think about it, that there's this global model, and periodically all of the GPUs are sharing their updates with that global model. The global model will aggregate all of those updates, and then the global model is pushed back to all of the GPUs, right? So that they're all benefiting from the respective training progress that they're making within the data center, right? So this is a standard way of training a neural network model with data parallelism. So it turns out that the way we implement this, we often don't have this separate parameter server that maintains the global model, but instead we are implementing this whole process in a decentralized way, where each GPU worker sort of trains on a subset of the data, but then the workers are all communicating with each other, for example, using a ring topology, and this is sort of when they're exchanging the training updates or the gradient updates that they have as part of their training. So those synchronization operations, they're implemented using collective communication, and that, for example, potentially adds a communication bottleneck to a data center, right? As you can imagine, sort of doing this kind of communication at scale across 100,000 GPUs that you may have in your data center is something that can be quite challenging. So this is sort of data parallelism. It's one of the main techniques that we use to do AI at scale. So what we're doing is we're replicating the model, and then we're sharding the training data. So the advantage the data parallelism has, it's very communication efficient, but we assume that the entire model that we're training fits into the memory of a single GPU. With some of the very large language models that we're using, this is no longer the case, right? So therefore, we have other techniques available, such as tensor parallelism. So what we do there, we're now sharding the model and replicating the training data, right? So because we're now essentially subdividing the model, we can now deal with much larger models, and we're no longer constrained by the amount of GPU memory that we have. We can also use pipeline parallelism, which is sort of another classical approach that has been known for a long time, how to parallelize computation, where we simply think of the computation in the neural network as being subdivided into pipeline stages, and we run those pipeline stages on different GPUs. So the nice thing about this technique is that it's model independent. So whereas tensor parallelism, when you're partitioning a model, you kind of have to look at the model architecture and figure it out for every single model in a bespoke way. The disadvantage of pipeline parallelism that it suffers from this problem of pipeline bubbles, which is sort of a standard challenge with any technique that uses pipeline parallelism. So all of those approaches that we can use in a data center to parallelize computation have advantages and disadvantages. So therefore, what do? We combine all of them. Right? And this is the state of the art. So we use essentially what is referred to as multidimensional parallelism, where we're using all of those different techniques in combination to kind of get the most effective way of then leveraging the GPU infrastructure that we have within our data center. Okay? So using that, we can now harness the GPUs and we can train models at scale, and we can also do inference using those models at scale. So So hopefully this sort of gives you some context in terms of how we leverage existing AI infrastructure. But what are some of the open challenges? Well, so one challenge is really related to this exponential growth that we've seen in the sizes of models that we are using, right? So I've mentioned Moore's law is something that exponentially improves the hardware that we have, right? So this is sort of one exponential growth that we had, but the exponential growth in terms of the model parameters is even faster than that. And increasingly, we're essentially seeing this gap between the improvements in hardware that we can achieve and ideally what AI models would like to have in terms of improvements to kind of be longer term feasible. And nobody really knows how to close this gap between sort of what AI models would like to have and what hardware can deliver. And in addition, because Moore's law is slowing down as an effect, sort of that gap becomes bigger and bigger, right? So one immediate consequence has been that organizations do not longer think that the way to improve large language models is simply to make them bigger, right? So those times are over. Now sort of people are thinking, well, how can we make them smarter so that they become more effective, but we don't need to add a larger number of model parameters that then obviously also makes the training and inference computation much more costly. So one effect of this has been that there's this big interest in other hardware technologies for accelerating AI computation. So as I've mentioned, sort of GPUs were first, and they were sort of almost lucky to kind of be able to benefit from the growth in the AI space. But now we see this much larger spectrum of different AI hardware that large companies and small startups are exploring, right? So there, for example, Google has their own acceleration architecture with TPUs. There's sort of other types of hardware chips that are being now created, and sort of nobody knows what really is going to become most successful within that space. And there's sort of an interesting comparison between GPUs and other types of accelerators, right? So GPUs have one fundamental drawback, that it's really hard to make them power efficient. And this is actually a property of the GPU architecture, right? So GPUs simply need to have particular behavior that means that they are quite power hungry as devices. Some of the other AI acceleration technologies that we're creating doesn't suffer from those problems, and they can be made more energy efficient. With GPUs, well, we have one vendor, NVIDIA, that is sort of quite dominating within that market. And they're not only dominating in terms of the hardware, but also in terms of the software stack, because they were the first. They established this CUDA-based software stack. So a lot of the AI applications that we have today, they've been written using those CUDA APIs. So using essentially the CUDA software stack. And so this means that it's difficult for many organizations to now shift from their AI models that were implemented for GPUs to some of those other AI acceleration technologies. But there are benefits to contemplate this shift. So one is the better power efficiency that AI accelerators have to achieve. AI accelerators, they can innovate in terms of the hardware designs, right? So coming back to this problem of the gap between model growth and Moore's law, right? So maybe we can close that gap by innovating in terms of hardware acceleration. And then finally, I sort of mentioned that communication can often be a bottleneck for these kinds of workloads. And again, sort of, if you have bespoke new hardware technologies, you can sort of innovate in terms of how communication happens when you do this large-scale parallel training with a large number of these AI accelerators. And there's sort of also interesting ongoing research work where people sort of trying to overcome some of those difficulties that we see. So it'll be interesting to see how the space will evolve over the next couple of years. So a second challenge that I want to mention is really on the software side, right? So how do we create flexible and efficient AI software stacks that then enable people to build AI applications, agentic applications, and so on top of those software stacks. And so here we have sort of two dominant ecosystems. So the PyTorch ecosystem is one. The other one is the TensorFlow JAX ecosystem that is being developed by Google. So a lot of people using those software stacks, they are familiar with the user-facing APIs that are usually Python APIs. So Python is the dominant programming language that a lot of people use to implement AI models. But that's actually not how they're being executed by the hardware, right? So what happens is that sort of only the top layer in your software stack is Python, and then you have other layers, such as, for example, a compilation layer that then looks at the representation of the AI model and essentially thinks, how do we transform and optimize it into the most efficient representation so that it can be executed on the underlying hardware? And this is sort of another area with a lot of ongoing research and a lot of interesting challenges in computer science, right? So what are new types of compilation techniques to make AI workloads more efficient, to parallelize them better, to take a better advantage of the properties of the hardware that we have in data centers? So then the lowest layer of an AI stack is the runtime. So this is sort of what then really interacts with the hardware and executes that computation, so then dispatches particular computational tasks to a large number of GPUs. And so an interesting challenge here is that this part really needs to adapt to changes in the AI infrastructure. And this is sort of something that people increasingly realize, that because a lot of AI applications are long running, the associated infrastructure is also going to change over time. So what do I mean by this kind of change? Well, so one example is that you're running some AI application and you may change the number of GPUs that you want to be using for that particular application. So this is an example of elasticity, where you want to move from one set of GPUs to, for example, a larger set of GPUs as additional GPUs become available, right? Another example of adaptation is failure, right? So as soon as you have large infrastructure, there is going to be failure. So failure will not be an exceptional case. It will be a common case, simply because of the large number of compute elements that you now have. So we therefore need very effective ways of reacting to failure and not disrupting the execution of your AI application. And then finally, as with any large infrastructure, you need to maintain it, so you may have to redeploy particular computation, move it around. So you need to have sort of management flexibility to change existing computation. So all of those three things are examples of changes that occur when an AI application executes. So the challenge is really, what are the right abstractions that we should have in the software stack to better support this kind of change and sort of give the required flexibility, right? And people are sort of only now starting to think about some of those problems and coming up with really interesting solutions. So I want to mention one last challenge, and this is related to sustainability, right? So as you can imagine, from that infrastructure at scale, well, how do we make this sustainable? And this is a big challenge. So here you can see sort of one way of looking at that problem in terms of CO2 emissions. So this is sort of an attempt to model the impact on carbon emissions of the training of a large language model in comparison to some other human activities, such as, for example, well, sort of the carbon footprint of a human over 1 year, or the carbon footprint of air travel, right? And you can sort of see that training something like the GPT-3 model, it has quite a significant amount of CO2 emissions. I mean, these kinds of comparisons have to be taken with a grain of salt. It's actually really challenging to accurately model, for example, the carbon footprint of training a large language model, right? So for example, how do you think about the embodied carbon that exists in the GPU infrastructure that you had to create? So sort of like there's a lot of ongoing work where people are really trying to develop new methodologies to really understand the extent of that problem. But there's still it is a fact that the environmental impact of the infrastructure that we are creating is very, very significant, right? And we currently sort of don't seem to have any good solutions that would sort of sufficiently make a difference overall in what is happening in this space. So to kind of illustrate the problem, I just want to kind of show you the evolution of current GPU technology in terms of power consumption, in terms of its electricity demand. So this is what a latest generation NVIDIA GPU looks like, mounted in a rack in a data center. So the part here on the left that has the red frame, that's the actual GPU hardware. The part here on the right is only cooling infrastructure that you require for that GPU infrastructure, right? So this is sort of what it has come to, that we now essentially struggle to essentially cool the hardware, and obviously all of this adds to the electricity demand. If you look at the evolution of the electricity demand, so these are different generations of NVIDIA GPUs, so different microarchitectures, and you can see here the power demand in kilowatts of one of those racks. So essentially the power demand of this cabinet full of GPUs. And you can see how this has been growing, and essentially the next generation that NVIDIA is going to release next year, a single rack will have a power demand of 0.5 megawatt. Right? So to put this in perspective, 0.5 megawatt, with 0.5 megawatt you can supply about 500 average UK homes. Right? And this is a single rack that we're installing in a data center, and now sort of scale this up to a size of a complete data center that will have a very large number of those racks. Right? So this is why sort of supplying power is just one of the big challenges that we face in this space. And sort of to make a difference here, we're not looking for a 20% efficiency improvement, right? Or 40% efficiency improvement. That's not going to be enough, right? So we need essentially radically new solutions that cut things down by an order of magnitude or 2 orders of magnitude to really make this sustainable. Okay? So I want to leave you with sort of one other comparison point. So this is a table that tries to compare the training of a large language model with the operation of the human brain across different dimensions. And again, sort of this comparison has to be taken with a grain of salt, but sort of it's still quite interesting to do this. So when we, for example, look at the number of parameters that we have, right? So in a large language model, today it's sort of in the billions of trillions. That's actually reasonably comparable to the number of neurons that a human brain has, right? In the order of 80 billion. Right? So there we're essentially creating synthetic systems that are quite similar. Well, the human brain also has 100 trillion synapses, right? And they sort of are responsible for the connectivity within the brain. They're actually quite poorly understood. So we sort of don't fully understand their role, and in particular their large number is something that we can't replicate synthetically, right? There's sort of no way for us to create such a dense connectivity within a synthetic system, right? So this is one area where biology clearly managed to create something that we don't know how to replicate. When we look at the amount of training data that we use, like let's say it's sort of terabytes for a large language model, well, the human brain does this sort of lifelong learning, right? So our training data is essentially the continuous sensory input that we get over a human lifetime. Again, if you sort of try to quantify this, you're probably only looking at a couple of petabytes of data, right? So it's actually, again, like not that much, and we're sort of, well, we could move into that ballpark in terms of training data. In terms of processing speed, again, things are very comparable, right? So we now build essentially exaflop systems. So flops are floating operations per second, so sort of a measure of how fast computation is being done. The human brain probably operates somewhere between 10 to 100 petaflops. It's actually sort of not that computationally capable, but well, that is sufficient. So we're kind of in the same ballpark here. In terms of memory, right? So the state of a large language model, maybe hundreds of gigabytes. sort of the human brain can probably record, well, petabytes of data. So again, like we're sort of somewhat off, but we can probably close that gap. The one dimension where we're really far off is power consumption, right? So as I've sort of mentioned, training a large language model on GPUs, you're looking at kilowatts of power consumption, right? Whereas when you try to quantify the energy demand of a human brain, probably looking at 20 watts, something like this, to sustain it as a biological system, right? So it's incredibly energy efficient, right? And that's sort of where we need to get, right? So ideally, we would like to be able to build hardware that can, for example, train a large language model with a power budget of 20 watts, right? We don't know how to do this. So one of the things that the human brain is really good, it's good at exploiting sparsity in the computation, right? So a lot of the neural network architectures that we use today, such as transformers, they're dense architectures, right? The computation always affects almost all of the elements that exist in the neural network, and this is sort of where a lot of the power demand goes, right? Because we need to essentially do computation that touches every part of that neural network. That's not what the human brain does, right? The human brain is really sort of clever about activating particular parts depending on what is necessary, and obviously activating sort of small parts that then leads to those huge advantages in terms of the power consumption. So I think with something like this, we sort of see what the goal should be for any future evolution in terms of the technology. What we need to figure out sort of as scientists and innovators is how to get to that point to create essentially future sustainable AI systems at scale. So thank you very much.
So we'll not have discussions now at the end of the session. So let me invite the next speaker. Next speaker, Dr. Rohini Srivatsa, who is Senior Advisor on Business and AI Strategy, board member and professor. Dr. Srivatsa is a
So hand mic on karo do.
advisor on business and AI strategy, board member with 3 decades of experience spanning research, strategic consulting, and technology leadership. Rohini began her career in R&D, AT&T Bell Labs in the US, then provided to strategy consulting at BCG and IBM Consulting in India and emerging markets. Her R&D and strategy experiences converge into a decade-long journey as CTO, most recently as CTO of Microsoft India and South Asia. When elected Fellow of Indian National Academy of Engineering and the Indian National Science Academy, she holds an MBA from Wharton, PhD from UT Austin, and serves as an adjunct faculty at ISB, Indian School of Business, Executive Education. Thank you, Rohini, for being here.
Okay, good morning. I am told that I will need to move it from here, so we will manage that. Okay. I think given that 11:15, I'm going to try to bring our schedule back to perhaps on time. My talk is going to be quite different. I'm going to talk about the use of digital public infrastructure and how India has looked at public infrastructure, particularly technology infrastructure, and I'll take the perspective of private innovation as being the primary aspect for it. Don't get worried about the long agenda. I will try to move it fast. Okay, so setting the context. As some of you may know, India is a very large and diverse country. 1.4 billion people. It's a very young country. 22 official languages, pretty strong rural population, but a country that's getting very digitally enabled in terms of number of mobile connections, internet users. Note the very small number of people who pay income tax. It's a very, very different country, very challenging country, okay? For context, depending on the country you're coming from, if you saw India and you saw multiple countries, the country you're coming from, UK, is about the size of Karnataka, the state I come from. But if you look at the number of different countries which can pretty much subsume in India, it actually gives you a sense for how big India is. It's also a very diverse country, very, very economically divided. Reason I'm giving all of these is because it gives you a context for why technology in India needs to be the way it is. The scale, the complexity, the simplicity, the inclusion, all of those elements are the reason I'm giving this context. So India is actually 3 economies. There's one Scandinavian India that goes around the world, that buys luxury goods, that takes luxury vacations, that codes, that consumes. Then there is what you may call a Southeast Asia India, which is working, is aspirational. But then there is a very large sub-Saharan India that needs to be included. And therefore, the opportunity and the challenge is to make sure we combine these 3. Sorry, I'm having to be here because I need to move the slides. So this becomes inclusion as a very important imperative of how technology is seen in India. So we all know that we build public infrastructure in the physical world. All of us are familiar with it. But as societies are becoming digital, the whole idea of infrastructure needs to move to the digital world. And in some ways, India has seen this as an opportunity and a challenge to take the country using digital world in a way that can address the challenges of inclusions, of scale, of entrepreneurship, which is what I'm going to talk about today. So this is a book, if you are interested, you may want to read. It's called Samaj Sarkar Bazaar. Basically, it's a Hindi word for society, state, markets. The idea, it's by Rohini Nilekani, who's the partner of Nandan Nilekani. It's a good book to understand the thinking behind digital public infrastructure, why it needs to be public commons, and why it needs to put the society at the center of how digitization, digital economies develop. And this is a fundamental thinking that India has taken. So it's a very quick sense of India's DPI journey. DPI stands for Digital Public Infrastructure. Most countries, many countries I would say, have taken the view of the government developing major public infrastructure, even the digital world, whether it's identity, whether it is public distribution systems, etc. There are countries, namely particularly the US, which has taken the market side of it. India has taken the digital public infrastructure view, which I also talked about, which is a combination of markets, the government, and society. And I'll show you with examples what that means. So typically when you hear about India's DPI, you may hear the term called India Stack. That term is a little bit now dated. Most people now understand this to be digital public infrastructure. And at the very foundational level, it has 3 things: the identity layer, the payments layer, and the data/consent layer. Fundamentally, if you look at these 3, in the digital world, if you can demonstrate between 2 parties, if there's a transaction, if you can prove I am who I am, if you can transfer digital goods in a secure, compliant, and trustworthy manner, and you can pay, then a transaction is complete. So in some very foundational manner, these 3 become the foundation on the way in which this infrastructure is developing. And I'll explain the rationale and thinking beyond this. So if you look at the identity, it's called Aadhaar. Aadhaar is the Hindi word for foundation. Today, 1.3 billion residents in India have a digital identity. Now, many parts of the world think about the identity as to a lot of data, what is privacy, etc. But the approach that has been taken in India is minimalistic, scale what works. scale what works. So all the identity, what it does is to prove I am who I say I am. That's it. So the number of fields it has is very, very minimal. It has resulted in major reduction in duplication fraud, and it's a foundation for many services, and I'll talk to you about that. The next one you may have heard of is called UPI, which is the Unified Payments Interface. Today, this is transacting about 20 billion transactions per month, of the order of 300 billion US dollars in a month. That's the amount of transactions that have happened. It is pretty much the world's largest retail payment network, and it is today doing more payments in India more than the credit cards, debit cards combined. It's fundamental to way in the digital economy perceives. In fact, today if you go to a bazaar, to a market in the street, and you buy something and you give the person cash, the person will look at you strangely. Why are you giving me cash? I've got a QR code here, just pay digitally. It's become fundamental to the way even the lowest income people transact today, right? And that has got implications in the way you think about the economy, in the way you think about data. The last one, I'll give an example. So I gave you about 3 layers. I talked about identity, the payments, and then I talked about data consent. Data consent layer has got different manifestations. One of them is DigiLocker. DigiLocker allows for paperless workflows. And today it is developing, it is one of the newer DPIs, but it is developing the kind of scale to have number of registered users and a lot of services that are using DigiLocker to do paperless services. Let me give you a sense for what this has meant for India and why it is getting the attention from the World Bank, from organizations around the world, from the United Nations, etc., and also in many parts of the world. If you look at, I'll give a few data points. One is of financial inclusion. So back in 2008, the data showed that only about 17% of people in India had a bank account. And some $50 billion were being spent on direct subsidy. There was leakage, there was wastage, etc., etc. The Bank of International Settlements did a projection of how long it will take India, based on the normal data that they had, to get to above 80% bank penetration. And they said it will take 46 years. It could be done in 6 years. And the reason that could happen is because of the combination of what is called the JAM Trinity. It's called the Janadhan, which is the government came up with every person should have a zero savings bank account. The ability for identity to accelerate the KYC, which is called Know Your Customer in the banking world, as well as the mobile penetration. Over the last decade, India has built the world's largest direct benefit transfer system. And this really, from a timing perspective, came up very significantly during the COVID times, where many parts of the world were writing checks. India was able to put money in the banks of people who needed the money directly. And that, in fact, has brought resilience, and in many ways was during the COVID times, was fully leveraged. So if I just summarize and don't want to go too much into it, but I think the impact of this digital infrastructure at the very fundamental level, whether it's the identity, payments, and consent and data sharing, there are a few things, and I'll come to that in terms of what it means for the private sector, because that's the main thesis of my talk. Why while the term public is there, is actually mostly about private innovation. The public is just the foundation. So today, market expansion, the cost of eKYC, which is customer acquisition cost, has dramatically come down. The market is expanded because small and medium businesses, underserved markets are now part of the digital economy. There is measurement to say that in 2022, India's GDP, there was an uplift of 0.9% because of DPIs, and that's expected to grow. Of course, the fact that you have public rails brings trust, resilience, and it is a innovation foundation for startups and innovation. Now, from the point about from the foundational infrastructure I talked about identity, payments, and data, now the world has moved to digital public infrastructure for various sectors. Okay, so you have sectors, health-based DPIs, you have financial services, energy, education, agriculture. All of these are in different stages of development, execution, adoption, maturity. The reason, because each sector has its own challenges that need to be addressed. One of the ones I'll talk about is the need for credit. So you think about a vegetable vendor who doesn't have too much bank balance, but has fairly stable and fairly predictable cash flows, which means the person buys something in the morning and sells over the day and has deposit that goes in the evening, has fairly predictable and well established cash flows. But a lot of the credit in the traditional world happens based on assets and not cash flows. So is there a way to move the digital economy in a way that you can look at the digital footprints of what a person does over their life cycle? In fact, there is a very good book, if you're into this, called The Economics of the Poor. It was a World Bank study that studied some 50 families in Bangladesh, India, and South Africa. And a lot of very interesting insights from there that are playing into this. So one of the fundamental problems that the India stack tries to solve for is access to credit. So for banking financial services, there is a DPI called account aggregator. So here is the thing. ये बार-बार क्यों connection टूट रहा है यार? Okay. So in the traditional world, if you see on the left-hand side here, without an account aggregator framework, if I wanted a loan, I would go to the different banks and insurance companies where I have my accounts. I'll probably get my salary statement, all of that paper-wise. I'll go and pick it up and take it to the bank from where I'm trying to get credit. What the account aggregator framework does, if you see on the left-hand side, is as a consumer, if I give consent to an account aggregator, which is basically a consent manager, the consent manager then requests data from the different financial information providers, provides it from the secure data flow to the information user, and provides you the credit. There are multiple aspects to it in terms of how is that data used, is it used for purpose, et cetera, which I will not get into. But in many ways, it changes the nature in which the banking system, the financial system works. And this is one of the DPIs which is in early stages of, or rather I wouldn't say early stages by India standards. But if you look at this ecosystem, I talked about, on the left-hand side, I talked about FI, financial information providers, users, et cetera, right? This is what India does in terms of ecosystems. Now you look at each of the logos here is a startup that is working as one of the entities in that ecosystem. So look at the exponential growth of when you are able to provide basic protocols, standards of, see, by the way, we may think DPI is something that is somewhere out there. We all use it every day. If you look at email, it's a DPI. Email, SMTP server, it's a protocol that we use every day. It allows you to work with Google Mail to Microsoft Mail to etc. It's a DPI. Same way if you use the World Wide Web, it's a DPI. It allows you to look at information using HTTP protocol across multiple information systems. So we actually use DPIs every day. Okay, it's not a strange animal. It's just that in India, we have found those pressure points that if you address can unlock exponential changes, okay? And this is one of them, which then when it brings the ability to share data between financial information users, providers in a consent-based, secure manner, can unlock a startup ecosystem in an exponential manner. Okay? And that's the problem that needs to be solved with credit, which goes back to my point about while it's called digital public infrastructure, it's actually mostly about private innovation. Okay? So, what happens with startups come into the picture? So if you look at, I talked about a few sectors where there are education, healthcare, etc., where there are DPIs coming into play. All of these, of course, Amazon is not a startup, but many of these are leveraging this infrastructure to become either digitally transformed or completely change business models. Okay, so in each of these sectors, these DPIs are creating that friction-free ability to innovate. Okay, and that's what's happening. So I'll give an example. So for example, Zerodha. Zerodha is a startup in India. It's today, it has democratized, changed the way in which consumers participate in the markets in India. It's completely changed the way in which private people like you and I, who never invested in the markets, invest today in the markets. Okay, so it's the country's largest retail brokerage, which is one of the reasons why Indian markets are reasonably, the money flow is very much given by the Indian consumer today. It's not as much dependent on FDIs. Okay? That changes the way in which markets function, economies function. So here what Zerodha has done, it's basically used everything from the India stack. It's using eKYC Aadhaar for digital identity, for acquiring customers. It's using DigiLocker for document verification. It's using account aggregator to secure consent-based data flows. It's using UPI for payments. Okay, and the scale at which it was able to grow at a national market level could have not happened without this infrastructure. So this is the reason I'm giving this example is to tell you that the public in UPI is actually private. It's mostly private innovation. Okay. Looking at the time, I'm good. Okay, so for India to become a 30 trillion economy, startups are going to be core. Startups are going to be core for India's development for multiple reasons. One is the infrastructure. Second, some of the earlier points I made about the demographic dividend. The fact that economic inequalities are so drastic, there is no way the big corporates can provide employment. Okay, it is going to be about startups. It is going to be about the ability to really solve problems at the grounds up level. So India is going to become a major startup nation. In fact, Nandan has been quoted to say that in 2015 we had about 2,000 startups. Today we have 150,000 startups. By 2035 we expect to have 1 million startups. And I think this is probably going to exceed this because it's exponential. See, these things play off each other. Identity, payments, etc. Once they are there, then they play off each other. Taxes play off each other. Logistics, e-commerce, they all play off each other. So it's a very, very private innovation engine that India is putting in place. AI. So in fact, the most recent Economist article, which talks about 2026 and beyond, there is an article in there by Nandan called AI will change India and India will change AI. Of course, AI will change India just like it will change any economy. But in India, given the language, given the mobile penetration, given challenges of education, healthcare, agriculture, there are sectors which will get transformed with AI that could not have happened otherwise. In many ways that Peter also spoke about as to what AI can do in terms of vision, whether it's in terms of language, context, etc. etc. But the point about India will change AI is perhaps worth having a couple of moments on. In many parts of the world, what India has in terms of diversity, complexity, it's a representation of what's happening in many parts of the world. In fact, if you look at 7 billion of people who are outside of the rich world, their problems are very represented in India. So the way India thinks about AI, in the way in which multilinguality, in the way in which AI needs to be developed from big models to small models, edge AI, language, ruggedness, all of those issues will shape how AI develops. And it's just inevitable. If you look at the kind of energy consumption you're talking about, and you imagine the entire world of 8 billion people want that kind of thing, there is just no way this planet can support it. So India will fundamentally have to, for necessity, will have to think about AI from sustainability, from inclusion, from language, diversity, ruggedness, scale. All of these issues will become a test bed for how the world adopts AI. That's what I mean by saying India will change AI. In one way, India is already doing it. As I mentioned in my first slide gave you the context is quite important. And India is a mobile first, voice first market. What you have on the left is all the languages in India, 22 major languages in our constitution. If you look at the number of dialects, it goes into thousands. And Kaleka is here, she works very deeply in that space. To be able to provide inclusion for somebody sitting in Manipur, this tiny little state here, using AI with voice needs different thinking. And that's one of the things that Bhashini is doing, which is what I mean by, it's a national language translation mission, it's a platform. It's bringing together, again, ecosystems. In India, you have to think ecosystems. The scale is so big, it is so diverse, you have to think ecosystems. So the ability to bring language together using data providers, data model builders, startups, is one way in which India is looking at AI as being a DPI. How can it be a DPI to help people build using AI? Okay. So we had last year the first global DPI conference in Cairo. This second one happened in Cape Town just a couple of weeks back. More than 100 countries have participated because countries are seeing that their ability to digitally transform in a way that can scale, that can look at diverse requirements, inclusion, is bringing them to the thinking that India has pulled together. So 100 countries participated. It's about private sector innovation, like I mentioned. Now India is playing both a model country as well as a partner country in this space. So this space is growing. It is something that, of course, India's journey will continue, but from a global perspective, there is contribution also happening. Okay, that's it. Thank you.
Discussion for 10 minutes, not 20 minutes. And so, and then we can continue discussion over lunch and dinner and stuff. So feel free to give your insights into two lectures that we heard. Yeah, please go ahead. Yeah.
Driver for bigger AI models, data centers, outpacing more and more. And on the next talk, we've got an exponentially growing ecosystem of digital services, some of which will be AI powered. There's some really good inclusion drivers and good sort of rationales for that. How do we make that scale? That's going to be how do we scale it? Second, so do we have a sense for what the conversational requirements of serving the whole of India with that stack?
How fast is the footprint of the DPI stuff growing, and is there like a minimal set that would be the thing you kept, how can you? Are people asking questions about how expensive the new services coming on into the DPI are? I guess is what I'm asking.
I think it's a great question, and no, I think I can. I think it's a great question. I would say that the DPI itself, the identity, payments, etc., those are already scaled at national level. In some of them, the AI, and I would use the term a little bit broadly to say machine learning, some of those, not just AI. Some of them are already being used for fraud detection, for example, for operational efficiency. Many of them that's already happening. The place where the use of AI, particularly the example I gave on Bhashini, which is the language part, that is where some of the language inclusion efforts really play into the picture. I think I don't think India is taking sort of a top-down, I'll solve everything kind of approach. I think India is taking a very federated and at the edge approach. For example, in India, if an AI cannot work on my mobile phone, it's practically useless because one, I may be in a place where the connectivity is not, like I can't go to the cloud, right? So it's not going to happen. The smartphone penetration is good enough, and this thing is getting more and more intelligent. So a lot of those use cases, whether it's healthcare, education, are happening. So India will take a view of not just slapping AI on problems, but taking a view of what works at scale. And what works at scale that solves real problems. Now, because India is big, I'm sort of giving an example of sectors which the government cares about, like education, healthcare, etc. But if you look at startups, right, they are building for India, they are building for the world, they are going after multiple markets. They are working on sort of agentic AI with the very latest of it, right? So they are working slightly differently. Then if you look at the IT services companies, they are using AI for some of the coding and some of the service delivery, etc. So there is, it's not one answer, which is why there is not one solution.
That's really useful.
Yeah, so maybe one point to add is, I think it's an interesting question to think about how we should be providing infrastructure for AI at the scale of a country. And I guess one of the things that we've definitely seen in terms of the evolution of technology, that economies of scale really matter, right? And this is sort of one of the big drivers why we've seen sort of this trend towards sort of mega data centers, where sort of a lot of hardware is put in a single place, because it enables organizations to exploit these kinds of economies of scale. And this is sort of why a lot of the technology companies have been focusing on that. But then they're sort of reaching essentially limits in terms of, well, how much compute can you sustain at a single location, right? So therefore, sort of the longer term path needs to be infrastructure that is more federated, that sort of brings different parts together. We don't fully know how to do this effectively, because one of the challenges around federated infrastructure, it adds more complexity, right? Sort of it removes that simplicity of kind of centralized management that a lot of organizations prefer. So this is sort of one really open challenge that we kind of need to figure out how to do federation effectively of that infrastructure. I think another interesting point is really the split between cloud and edge infrastructure, right? Because I think we need both, and it is sort of something that we're seeing evolving, where there's sort of the big centralized cloud infrastructure, but it's being complemented by resources at the edge. But we sort of still don't know how to split things in the right way between cloud and edge. And edge, at least today, cannot achieve the efficiency that we again have from centralized infrastructure. So once we need significant resources, we kind of tend to then focus on cloud and not on edge. So all of those are kind of ongoing ideas that people are exploring, and I think figuring out a new solution will be crucial to kind of provide a infrastructure at a scale of countries.
Ask another one. Go ahead.
I can ask you a question, please. So when you mentioned DPI or AI is the next sort of DPI, but I do wonder, in the case of DPI, it's clear that you need an identity to power certain services, and you can measure or predict potential return on investment. If we need to unlock credit, we can unlock certain services because we can now identify identity of people. With AI, the returns on investment is proof. We're still trying to prove. Okay. Unused it. So with DPI, we sort of can understand the value of identity in the financial services sector. So understanding how we can do the KYC, we can give people accounts, bank accounts, we can give people mobile phone accounts, etc., and we know the value of that in various sectors. With AI, we have not yet proven ROI in many sectors. Right. So ROI on healthcare apps, ROI on chatbot apps, on AI in agriculture, yet to be proven. Are we just And I don't know whether there's a view in India on this, on the hype to adopt AI at scale very quickly, but not quite understanding how we're going to finance it, or how we're going to, what's the return on investment on all that digital public good we're creating for the profit of private companies, and how we're going to get the returns on that, and who's going to profit, because maybe, how are these startups based in India, are these startups based in other countries, or are these startups going to be overtaken by hyperscalers as well? What's your thoughts on that?
Yeah, so I think there are two different points I'll make there. One is, and sort of also picking up a little bit on Peter's point, is there is a desire and there's effort happening on foundational models, and I will not use the word LLM. Foundational models, could be SLM, it could be, which are bringing India's corpus into the foundation models. That work is happening along with the government, the India AI mission, etc. I would say that when I said AI as DPI, don't take it to mean that we're sort of AI washing every DPI. I don't think that's the intent. The intent is that the idea of a DPI, an idea of a public infrastructure, a public service that can multiply, use by multiple parties, and language becomes a very classic example of it. Because language becomes, in India's context, voice to voice, voice to text, transliteration, etc. It becomes one of those killer apps in some ways, a killer AI that is usable across all sectors. So then having that as a DPI is the ROI of it is across the economy. I mean, you think about inclusion, you think about the ability for people in different parts of the vernacular, access to education, information, employment, all of that, right? The ROI becomes, from an economic perspective, fairly straightforward. Now, I think the ability to then look at AI for different sectors, today I don't think there is a sort of national level thing to say we apply AI to all sectors. I think it will become, for that sector, for those use cases, depending on what the startup is trying to do, it will become a lot more contextualized, a lot more sector-wise developed. So the idea of AI as DPI is then idea for national level things for which you can see that national scale have impact. Exactly. Yeah. Exactly. But to just say, in healthcare is, for example, early diagnostics, the ability for a mobile phone to do early detection of oral cancer, etc. Is that, yeah, it's an amazing use case. I would maybe then create that as a DPI or some kind of a service for healthcare applications in a way that makes sense in that ecosystem.
So thank you for that. I think another way this raises some real sort of societal questions, doesn't it, about what good, public good is, and thinking sort of across to we're doing increasingly large amounts of computation, and I don't think as most societies are talking about good, they're talking about money or something, and so I wonder how we get a sense of what's the value produced from all that energy in computation. And I think one of the things that DPI is sort of asking is, well, here's some foundations that actually benefit people at a large scale. And I wonder if one of the questions for sustainability is, how much do we put into LLMs and just getting more parameters there? And is that producing actual good for society? So Peter, do you have a sense for how much computation we're doing is good versus less good? I probably have a view on what less good is.
Yeah. That's right. So yeah, so I think so I agree that I think one of the big difficulties at the moment across the industry is that it's not clear what the killer applications are going to be for some of those technologies, right? And there's sort of a lot of well, hope and excitement. There's sort of a lot of application of foundation models across different sectors. There's some initial results. We don't have the broad killer application that can essentially generate the types of revenue streams that would make this sustainable, where people would really sort of argue that, yeah, that there's enough value that essentially, well, consumers, businesses are willing to pay for this, right? So people are talking about productivity gains. It's sort of happening in some sectors to a certain degree. But for example, like hallucinations are a huge, huge problem, right? So it seems that, for example, a lot of agentic workflows work well in areas where you can validate the response, right? You can essentially look at the response and there's some cheap process for then figuring out, is it correct, is it not correct, right? Obviously, in sort of a lot of the sectors where we want to use LLMs to improve productivity, that is not the case, right? You get a report written and then you either believe it or you don't believe it, right? That is a problem. So to me, like, well, killer applications don't exist until they do, right? And it sort of just takes like some particular sector embracing something that becomes a game changer, and then we can sort of have essentially this exponential process in terms of adoption. So I think this is sort of something that may happen. I think the other thing is that even small efficiency improvements reduce the cost per, for example, LLM inference requests, and that can make a difference between something not being viable for a particular application versus becoming viable. And therefore, sort of across the industry, there's a lot of demand in reducing per LLM inference costs to essentially unlock new use cases and make them economically viable.
I think maybe a segue to the next session as well. In that, you mentioned language translation, Rohini, and you're talking about compute efficiency. So there's something called Jevons paradox. So if you make something cheaper, more people use it. Language translation opens up access to many more people across India, and also, so differently from identity, digital identities, AI opens up lots of opportunities for misuse, right? Rather than fixing a problem. Maybe talk about cybersecurity in a second. What's your view on, if we do unlock that AI ecosystem with, for example, language translation, has India got a view on the potential costs that will be incurred both in terms of energy consumption and potential scams and crime that will be, opportunities that will arise as a result? I don't know. Any thoughts on that?
Yeah, I think that's true for any digital economy. Even if you didn't have AI, right? If you have an economy that is getting more and more deeply in terms of, let's say, money transactions, the need to then make people aware of what could be fraudsters, those are there. We are facing that, right? I mean, that's one of the reasons. There's a lot of work happening in terms of just not just awareness, but also using AI for fraud detection. I mean, a lot of that is also happening, right? Now, if you say that, to me, I think the question that you're asking is, the question becomes is that, is my choice not to give language translation to millions who would have access to healthcare, etc., just because somehow there is going to be more fraud? That's like a global economic question. Should we just stop AI because, right? So I think that and Kalika here has worked on the AI governance work that India is doing, and I worked on some of this work several years back. So there is enough happening by way of AI, not just AI, but digital governance, data governance. The PDP Act is now active, without regulating it. Because India as a country is, if we just burden the startup with the regulation, unlike Europe, we will, our economy will not be able to. So I think the broader question is, how do we do this safely in a way that a country of this scale and this diversity and challenges leverages what could not have been possible earlier in any sector you are interested in, but do it in a way that's safe, which is not just technology problem, it's governance problem, it is societal awareness problem, it's education problem, which is no different than any other technology.
If I can add to what Varun said. Firstly, translation I do not think is a long-term sustainable thing at all for any country, including India, because we are talking about machine translation. Machine translation only does certain kinds of translations. It has no cultural nuances. There's no way to do those translations in any but very select, very yeah. So the translation thing is just a starting point. And the fact that we are building foundational models, there's so much effort going into curating data sets, etc. We are hoping that we don't have to rely on translation in the long term. So it's not like, build everything in English and then let's just translate it into Indian languages. Actually, in India, we are kind of sick of that build something, somewhere else for English or whatever, and let's just translate it. So I think we are at that moment in India that there are enough people who do not want that to happen. The second thing is about the safety thing. I could ask the same safety question for any part of the world, right? Deep fakes abound. There are lots of safety issues. If you read Yoshua's AI science report, you would believe that the world's coming to an end and we should not do anything, right? So, so the safety questions are not very different. The questions are not very different from any other part of the world. The practical implementations of those are different because we have the complexity of language, we have complexity of different kinds of populations here. And there are people who are working on that. So if you've looked at the AI governance guidelines, there are recommendations that we have, all kinds of risk assessment framework for the country. We have some kind of, a little bit more of regulation sector-wise for high-risk domains. And then there are people like Mayank who are working on very core safety tools for the country where, in areas especially where safety becomes like a big problem, So there are those things happening as well. So it's not as if the government doesn't have a view or India as a whole doesn't have a view on that. It's a difficult problem anywhere in the world and everybody is working towards it. So.
Scale differently depends on how much you pay. And the other thing about machine translation, I didn't mean to say translate everything from English to X. I was thinking across India, being able to translate. And that's hard. I know it's a hard problem. And we're doing.
Problem. You take any of the best state-of-the-art machine translation systems, and this is my favorite example, and ask it to translate. John and Mary had a key lime pie that they had to divide into 3 parts, and ask it to translate it, the best one, and see what happens to key lime pie. Right? So.
Okay. I get the point. There are back and forth about not every dialogue is about the pie and 3-way cutting it, but anyhow, the complex things may be not translatable. But it's desirable that we move in that direction about translating real time so that there is greater communication across India, for example. Okay, that's desirable. Maybe we are not there, but it's going to happen. Now, I'll conclude by giving an example of a digital public infrastructure which is bringing lots of value to India, which also tells you about the context of technologies. For about 100 years, it was illegal in India to do surveying and mapping, believe it or not. So one day, while I was responsible, I was in a ministry that looks after surveying and mapping, and I woke up one morning. I wake up every morning. But that morning, I woke up and I said, hey, this map that I'm using is not an Indian map. The data is Indian. The people who made that map are sitting in Bangalore. I know them personally. And everything else, but you are not monetizing it here. So what's the reason? The reason is it was illegal to do surveying and mapping. You go to jail if you do that because of security. But that's total, with the new technology, there's no, everybody, your enemy has the same data as you do. So there's nothing you can hide. So we changed the policy, and I was saying, well, you can do surveying and mapping and 3D street views and everything. Any Indian entity can do that at any scale. Now the whole country is being mapped at 5 centimeter accuracy digitally. And so people think, well, this would have an impact of few $billion or tens of billions of dollars, but actually it's hundreds of billions of dollars. Lots of business building up on it, but more importantly, most people in India, rural people, they have no ownership paper for their land. So it's just total wasted resource because it's not working for your economy. And now they would get this with the digital mapping, they get ownership certificate, they can go to a bank and take loan against that as a collateral. So the impact on economy directly is hundreds of billions of dollars. All that land is going to work for you now, which was not operational earlier. And so government has set up what is called CORES, this continuously operating reference system, using which any person in village using a smartphone can do mapping at 10 centimeter accuracy. So the local bodies, panchayat and everything, the local bodies, they can do their governance, they can do all the survey mapping. They are not dependent on government, they are not dependent on companies to do that. If they, so this course, there's a network that government pays for, but the fruits are reaped by people everywhere locally. So anyway, we can conclude this session, and then a big round of applause for the two speakers that we had here. And then we start with the next lecture in a moment. Session 2 is about security, privacy, and digital trust for critical infrastructure. Our first speaker is Professor Stephen Murdoch, who is Professor of Security Engineering, Head of Information Security, and lead to the Foundational Computer Science section in University College London. His research is on payment system security, privacy enhancing technologies, online safety, and intersection of computer science and law. That's another area which is so hot, going to be hot in India, because our courts are completely, saturated with unresolved cases. He teaches at UCL in information security. He has worked with the Open Net Initiative, investigating internet censorship, and for the Tor project, improving the security. And well, anyhow, you get the idea that he's neck deep into security, privacy, and digital trust. Thank you.
Okay. Yes. Yeah, thank you for the introduction, and thank you for the invitation here. I'm going to be talking about the Cherry project and the work that we've been doing on this. Of course, this being a hardware and systems project, there's a long list of people involved in this. So a lot of the work that I'm presenting is done by some combination of these. So I'm going to talk about security and particularly memory safety vulnerabilities. So these are the type of error in software which leads to the largest proportion of security problems. There's various estimates for this. So one estimate that seems fairly consistent is about 70% of security vulnerabilities have their origin in memory safety problems. In Android, it's 90%. In Firefox, 94%. And a study that was done by the Google Project Zero found that of vulnerabilities that are zero-day exploits, i.e. they are exploited before any fix exists, that is 67% of those vulnerabilities are memory safety problems. And by memory safety problems, I mean things like buffer overflows. So if you have some data stored in a variable A that is a fixed length, and then you try to store something in there that's longer, so if you store the word excessive, that doesn't just cover the data in A, it also overwrites this variable which is next to it in memory. And sometimes that can be exploited to take control of the computer. So the reason that memory safety vulnerabilities exist is there's a mismatch between how programmers think about the software they're writing and how the hardware deals with those programs in operation. So if you're writing programs, you think about variables. So you store data in a variable. These are different things, and they are not overlapping with other variables. And to make software more manageable, you don't just think about one bit of software, you organize that software into modules. It goes by different names depending on the programming language you're using, but different parts of the program that have different responsibility are in different modules. And because the problems that we're trying to solve with computers are quite large, the way that we deal with this is by splitting that large problem into several small sub-problems and then delegating responsibility for solving each of those small sub-programs to one part of that program. But from the hardware, it's very different. So that deals with the actual execution of what you're trying to do. It just knows about bytes in memory and pointers to particular locations in that memory. And whether these are variables is not something that the hardware even understands. All code and data is the same. So there is no distinction between code and data, and whether something is in one module or another is, again, not something that the hardware understands. And when you take your problem, you try to split it into tasks. When one of those sub-problems is delegated to a bit of code, when that code is executing, it has the same privileges as the code that is calling it. So it's like asking someone to do something on your behalf, but you don't just give them the ability to open up a door, but they could do absolutely anything with your life. So this distinction between what programmers think and what hardware does is the core reason for these memory safety vulnerabilities. So we're in a sustainability session, and security is a sustainability issue. So one is that sustainability means that you should be able to continue to do what you need to do. If someone is maliciously interfering with your system and they're not allowing you to do something, then that is a sustainability problem. But sometimes sustainability is seen in a much more narrow sense about efficient use of resources, and security is important here. In the UK, there is a rule now that when a piece of hardware is produced, it comes with a certain declared period of how long it is going to continue to receive security updates. How long does the manufacturer commit to fixing problems, including memory safety problems? Once this time has gone past, all good security guidelines say that you must throw this device away. It might do the job perfectly effectively, it might be working exactly as it should, but the manufacturer is no longer able to maintain this properly, and so it gets thrown away. So that's a waste of resources, and if there's a way of getting better security so that we don't have to invest so much resources into securing systems, then we'll be able to support the systems we have today for longer. So there's a recognized problem. We've talked about this memory safety vulnerability. It's really inherent to the types of hardware that we've had for the last few decades. How can we deal with this? Well, one is to use memory-safe languages. So these augment the program you write with checks to make sure that anything that happens is going to preserve memory safety properties. These are not entirely new, so Java has been around for quite a while, Go is another one, but one language that seems to have attracted particular attention here is the Rust programming language. So it has memory safety protections, it has some other nice security properties, it's very efficient, and so there's a lot of excitement about the potential for this. But it's not all good. So whenever a check is performed, that takes some extra time. And because this in practice happens serially with the operations that you're going to do, i.e. you must first of all do the check and then you do the thing you actually want to do, it does cause significant amount of overhead. It's not a massive amount, it might well be a good trade-off. But I think the real problem is that not the overhead of implementing these security checks in Rust, for example, it's that we're relying on billions of lines of code written in C and C++, and these are not memory-safe languages, and they cannot easily be made to do so. If we were to rewrite all this C and C++ into Rust, it would cost a fortune. So an optimistic metric for cost of a line of code is $15. So for Linux, just the kernel, not all the programs that go with it, that's about $500 million. Windows itself, again, not the applications, just the core operating system, that's close to $1 billion. So not only is it expensive, but if programmers are doing this, they're not actually doing anything useful. They're not advancing the state of the art, they're not generating any value, they're just fixing the problem with this old, important legacy code. So that's one problem with rewriting everything in Rust. We just don't have the resources to do it. Another one is that when you rewrite code, then you get problems. So Cloudflare announced a little while ago that they're going to rewrite their software in Rust. They're going to fix memory safety errors, very good reason. When people were applying for visas, you might have seen this screen. So this is a problem with Cloudflare. The reason that Cloudflare went down was because of a problem in Rust code. It wasn't a memory safety vulnerability. Rust does a pretty good job at preventing that, but it doesn't protect against logical errors. And the reason you get new logical errors when you rewrite code is because the code embeds the knowledge of the programmers which went about creating it. So knowledge about the problem that they're trying to solve, the solutions, the regulation around this, all this experience is embedded into this code, and it's often not written down anywhere else. So if you tell someone to rewrite code, they're probably going to make some mistakes because they will not realize the way that something was written was important. They will not realize the subtleties around this problem. And we see this. So Ubuntu Linux distribution is doing, again, a sensible thing from security perspective. It's writing the most security critical code in Rust, replacing the C and C++ code. And one of these most important bits of code is called sudo. Sudo allows you to temporarily take on system administrator privileges on Linux and Unix computers. It's been the source of many very serious security bugs. So it was rewritten in Rust, but not many months after it was first deployed, there's been several security vulnerabilities in this, and those are because of embedded knowledge in the C version of sudo, which was not translated over to the Rust version of sudo. So we've talked about this fundamental problem in hardware. Rewriting things in memory-safe languages is only part of the solution. So what else can we do? Well, we can revisit some of the assumptions of how we've been building hardware over the past decades. And back in the 1970s, there was a lot more of exploration of different models of building computer architectures. Many of these disappeared, some for good reason, some for not good reasons, and one of these lessons that turned out to be quite valuable is capability-based systems. And there's a picture of one of those computers down there, so that was developed at the University of Cambridge. And capability systems try to revisit the assumption of ambient authority. So ambient authority is where if you ask someone to do something, can they do that with the same rights as you or with some limited rights? So if you ask someone to sign a document on your behalf, does it mean they can sign every document or just that document? Computers normally work on the assumption of ambient authority where the delegate has the same capabilities as the person who's doing the delegation. In capability-based systems, there's mechanisms for efficiently delegating a restricted set of abilities. And based on that concept, you can build many new types of applications, including some which are important for security purposes. So capability is not a specific technology, it's a design pattern. You can implement this in many different ways, and because it's a design pattern, we can already use this today. And in fact, many secure applications now use something like capabilities. So what they try to do is delegate only what is necessary to carry out the particular task that they're going to do. So you divide your problem up into tasks, you understand what is the absolute minimum privileges you need for carrying out that subtask, and then that is what you get. And this is an instantiation of an existing good principle, which is the principle of least privilege. So when you're building a computer system, it should only be given the privileges that are necessary to do that task and nothing more. And another lesser known principle is the principle of intentional use, which is that the act of giving privilege to a particular module or a particular program is something that happens intentionally, not just by accident. And those two principles are the sort of fundamental basis for the Cherry design. Cherry needs modifications to computer hardware, but you can build capabilities on top of existing hardware because there is memory protection. And this is something that probably many of you have used without noticing it on macOS apps. So if you have a macOS app downloaded from the App Store, if you try to open a file, the thing that pops up is not the program that you think you're using. It's actually part of the operating system. And by selecting a file, you're not just telling the program, this is the file I want to open, you're delegating a capability to access that file to that program. And the nice property that this has is even if that program is misbehaving, it will not be able to access any other files. It is only able to access a file because you, as a human sitting at the computer, were able to do that. So this compartmentalization between the main program and the thing that's opening up the file is sometimes called sandboxing. And you can build that on normal computers, but it's very slow. So when you switch between different sandboxes, you could be throwing away hundreds of thousands of cycles of your computer because the context switch between different processes is very computationally expensive. So this is something that it can only be done rarely. So it's fine to do it each time you open a file, not fine if you're going to do this many, many times a second. So that's the concept of capabilities. I'm now going to talk a bit on how Cherry implements capabilities. But first of all, I'm going to come back to something I mentioned earlier, which is pointers. So what pointers are is the way that the computer hardware knows about memory and how can a program access a particular bit of memory. It has a pointer, and a pointer is just a number. It's an address of a particular location in memory, typically virtual memory. So you've got this pointer, 64 bits, and that tells you where in the memory is this bit of data that you're going to be operating on. So they're implemented as virtual addresses. They're just integer numbers, nothing special about them. You use them to point into particular locations in memory. And the way you get a pointer is you take another pointer and then you do some arithmetic. So you add or subtract numbers onto these. They're just numbers, so you can do arithmetic. Once you've got a pointer, you can dereference them, which means you can do something with the memory location where they point to. Because they're just numbers, there's no protection against modifying them. So you can come up with a number out of thin air, you can say this is a pointer, and then that is now going to be used as if it's a pointer. And that is one reason for these errors in memory safety. So if a pointer goes outside of the bounds it normally should execute, it normally should be allowed to, or it gets too big and is so large it loops around back to the start, that's another type of memory safety error. Any of those could eventually result in an exploitable security problem. And you can also use pointers in the wrong way. So you can have pointers to data, you can have pointers to code. If you use a pointer that's normally intended to point to code as if it's data, then you leak some information about that code. Or if you use a pointer that's meant to be used for execution and you pointed at data, now you're going to be executing something that should never have been executed in the first place. So the limitations of pointers is really the root cause of all of these memory safety vulnerabilities, and they're highly exploitable. If one of these exists, probably someone will be clever enough to exploit it. So what Cherry does is it replaces pointers with capabilities. You still have your virtual address here, but you've got another 64 plus 1 bits. One of these bits is the tag bit, and there is a tag bit for every location in memory, and this tells you whether a particular location is a capability or is it just data. And because this tag bit is under control of the operating system and the hardware, it's not something that an attacker is able to modify. So this gives provenance to capabilities. The other thing that is there is bounds. So you have, relative to the location in memory you're pointing to, you have a minimum and you have a maximum. Any attempt to use a capability outside of those bounds will be prevented. And that will cause an exception, then the operating system can do something with it. And in addition to the tag bit and the bounds, you've also got some access control bits. So you can say that this location in memory can be used for code, this location in memory can be used to be modified, or maybe it can only be used for reading data. And this means that when a particular capability is dereferenced, it can only be used for the operations that it is intended for. So going back to these problematic assumptions, how does this change when you replace pointers with capabilities? Well, one is that memory is no longer just a bunch of bytes that the hardware knows nothing about. It is defined potentially overlapping areas where each area is referred to by a capability, and that capability has the lowest point and the highest point where this capability can be used. Code and data are now treated separately because capabilities can be used for code or they can be used for data, and you can configure them so that they will never be used for both, so you will never accidentally confuse these. And delegation is now possible because If you have a capability, you can create a narrower capability. So you can do things like reducing the bounds, you can reduce the access control. However, if you have a capability and you're given one of these, you can never expand it. So it has the property of monotonicity, that as you're delegating, the privileges given to the party you're delegating to is always less or the same than the task which is performing the delegation. And Cherry is also highly efficient. So we can look at this in a number of different perspectives. One is the amount of chip area that needs to be dedicated towards implementing this extra functionality. A case study done is the OpenTitan CPU that was developed by Google to perform security critical tasks within data centers. Implementing Cherry on top of that was an overhead of roughly 1%. In terms of the effort that's required to take C and C++ and make it run in memory safe mode in Cherry, you've got to recompile it all, but the compiler exists, so that's a purely automated task. But for some code, you do need to modify it. So low-level code dealing with things like memory allocation needs to be aware of how to deal with pointers and how this behavior changes when pointers become capabilities. So FreeBSD kernel, 1.4% of lines needed to be changed. There was an implementation of some aspects of 5G from Ericsson. Again, about 1% of that needed to be changed. And compared to rewriting it in Rust, it's 1% versus 100%. There was also an experiment done with the KDE desktop environment and the X11 graphical system. That was only 0.03%. There's a few reasons that this is much smaller than the previous numbers. One is that there's been development in the compiler so that the compiler is more clever and is able to do more implementation of Cherry by itself. And then the second thing is that KDE and X11 are a much higher level code. It deals less with the minutiae of memory allocation, and that's therefore the code that is the hardest to deal with is only a relatively small proportion of it. It also has the efficiency property that the checks, because they're implemented in the hardware, happen in parallel with the data access. So that improves performance. But there's still performance overhead, and the reason for that is now, rather than processing 64-bit pointers, you're processing 128-bit capabilities. That doubles the storage space in cases that they're used. And the overhead depends very much on the task that's been performed. So if something is not very heavy on memory allocations, it's only about 1%. If it is very, very heavy on memory usage, then the highest that's been found is 165%. But some of that is down to the prototype nature of the hardware, and it definitely could be brought down with the hardware designed with capabilities based in all aspects of its design. And I mentioned about compartmentalization and sandboxing. On an ordinary computer, you can deal with tens of compartments. In the case of Cherry, you can have tens of thousands and very low overhead between transitioning between these compartments because you don't have the overhead that comes with switching the processes that are used in ordinary sandboxes. So there's plenty of implementations now of Cherry. Most of the figures I've been given have been from Morello, which is a prototype data center class ARM processor that was developed as a test bed. There's another work under development which is based around RISC-V. So that's sort of, could be used in many aspects, but one potential design goal is to be used in automotive systems. So it's powerful enough to run Linux, but it's not the data center class hardware that you have in Morello. And even smaller is the Cherry IoT microcontroller. It's a 32-bit RISC-V core, and that is what is implemented in the OpenTitan processor. That's the discussion of the hardware, but there's also software that's going to be needed. You don't just get the processor, you also need to have the compiler. So that's been implemented on top of LLVM, and that's developing all the time. There's a huge amount of work that's gone into the operating system. So this is Cherry BSD. There's also a Linux version that was developed by Codasip. And then you also have the application suite. So KDE, Chrome has been implemented to take advantage of Cherry. And this is continuing. Okay. So I think we're taking questions in the discussion section. Or is there anything that you want to talk about now? No. Okay, thank you.
Thank you. I invite the next speaker, Dr. J.P. Mukhopadhyay, who is from IIT Delhi.
Thanks.
Very involved in the secure and focusing on hardware security. He previously held position at IIT Delhi, NTU Singapore, IIT Shanghai, Brooklyn, IIT Madras, his research spans cryptographic engineering, micro-architectural security, hardware security, dependable AI, and encrypted applications, including homomorphic encryption and privacy preserving ML. He has published over 300 papers over leading editorial boards of senior editor of IEEE Tips, a recipient of many major awards in India, and a fellow of all the academies of science and engineering in India. The recognitions of it include Qualcomm Faculty Award, National Award, Soviet Fellowship, many others. Thank you very much for joining us.
Thank you very much for this kind invitation and also the kind introduction. So I will be kind of giving like an overview on some of the areas that I have been working on, which is basically in the area of hardware security. And I will try to kind of like illustrate that in security, right? I mean, you have to be optimist and pessimist at the same time. Okay, so that essentially I think is unique frame of mind that we need to bring into the game. So to begin with, hardware security kind of deals with the gap between theory and practice. So while we know that we have got a plethora of nice techniques to secure the world, but the fact remains that there is an absence of theory for the reality, and because of which even mathematically strong constructions can fail. So in particular, I will try to highlight the aspect of side channels, which are unintentional information leakage sources through which ciphers can be compromised and computations can leak. So nowadays, in the world of artificial intelligence and machine learning, this topic is not only constrained to like cryptographic techniques, but probably can extend much beyond that. So I will say, like, when we talk about chips, right, and the chips are being deployed throughout our infrastructure, it kind of questions the overall sustainability of systems. So talking about some statistics from India, we know that there are huge like increase in the number of hardware components that we procured in our devices, and that kind of questions like the amount of implication of this on the overall the national security. So in particular, I would like to mention that this problem is not only Indian problem, this is also a global problem. So this is, I would say, one of my recent favorite examples. This is called as bad audio malware, and it shows like a 3 years engagement of the malactors of trying to combine social engineering, computer science at the highest level, and also like various other supply chain infections to perform espionage in certain parts of the world. So this shows that like security can really be concerning when we are deploying, like hardware into various solutions. And this also kind of tells us that supply chain is very extremely important. So we take a very simple device, which is basically a low cost, and deploy it across various strategic, infrastructures. And when we deploy them, so we can deploy them on, like on smart grids, on SCADA systems, and on various other, critical infrastructures. But then the question is, right, how much security threats do they really bring into the real world? So this is, I would say, like this particular figure tries to kind of capture this fact that as the device goes from different endpoints, like it probably, while it has reached you, it has probably crossed 70 international boundaries. Okay, so you can imagine that trust is such distributed that it really becomes a conundrum to solve. So therefore, right, it really needs an addressal, and therefore, right, I would like to mention that we need to kind of combine our approach. So in computer science algorithms, there are certain techniques, and particularly one technique is called as baby step, giant step, which means that you kind of try to look at the problem in parts and also in totality. So when we look at in parts, in particular, I will try to highlight about the thing that I work on, which is called as side channel attacks. And then we'll try to kind of get a more holistic overview of this. So when we talk about side channel analysis, right, what do they really mean? So they mean that basically, like, they are channels through which your computations can leak in the real world. So you can think about a benignly looking if-else statement, and if that depends upon secret information, it can get compromised, it can leak. So in particular, I think this topic, this discourse became more studied by this very nice paper by Paul Kocher and his team in around 1997, when they defined what is called as power-based side channels, which basically means that when you are measuring power, so it could be also other side channels, but let's talk about power. Then, because of the fact that the power consumption depends upon the underlying operation, because the power consumption depends upon the underlying data, there are different types of power analysis techniques that can evolve. They're called as simple power analysis and differential power analysis. So therefore, right, what kind of threats do these kind of, attacks bring in? So this paper is also another very interesting one, which was published in IEEE Security and Privacy by an Israeli team to show that how, when you are deploying such kind of devices, which could be, like smart automation systems in various buildings, then and they have a feature. Which is called as over-the-air updates. So basically means that when you are kind of updating them, then you need to do a whitelisting. And the whitelisting is often done in this case by performing an AES check. So what the attackers did is they performed, a side channel attack on one of these devices. And once you get the key, they showed how they can control and command and spread worms across these networks. And the projection was that you can actually really, blind a city as big as probably Paris or Delhi. So therefore, security, looking at the chips from the point of view of the chips is super important. And that is why we built this lab, which is called as a Secured Embedded Architecture Lab, or SEAL, nothing to do with the US SEAL. So, we try to look at side channel attacks, but also at various other aspects of the overall gamut of cryptographic techniques, like privacy enabling techniques and so on. So in particular, I would like to kind of give you a quick overview about how our lab looks like. So please. So basically, like, this is a very quick overview on the various kind of hardware analysis that we do in this in the world of hardware security. So this is a tool that we also developed for side channel evaluation, which we called as ESP Anveshak. So Anveshak basically is an Indian word standing for analysis. So now I'll try to get into like some of the details of what we are doing. So in particular, we know that AES or any other standard cipher, right, which is deployed in various security devices, are extremely nicely constructed, and therefore, right, you can pretty much be sure that they're nicely mathematically constructed ciphers. In fact, AES recently became the 25 years, like world, the de facto block cipher around the world. So there is no real problem in the algorithm, but when you implement them, then there can be several concerns. So in particular, imagine that there is an AES engine that is running, and at some point there is a fault that is injected due to certain methods. And when the fault spreads, and then you essentially observe the faulty outputs, you can actually form systems of equations which can trivially leak the key. So that basically means that the implication of faults on security is quite paramount. So that is one class of attacks which are called as fault-based cryptanalysis. And this has a significant sort of impact on modern day computing systems. For example, one of the very important examples which was kind of, which affected Intel's series of processors which are called as SGX is called as Plundervolt. So in this particular class of attacks, people try to kind of play around with the voltage frequency scaling, and using that they could inject the faults using purely software techniques. Now once those faults are inflicted, you can perform those attacks that we mentioned just now to get the secret key. So now there are other methods also which people have shown how to trigger faults. For example, these could be reliability issues. Like imagine that you have got memories in your computing devices, and these memories, often which are called as DRAMs, need certain amount of refresh rate to remember their data. Typically in the context of DRAM, it's something like 64 milliseconds. So there is a class of attacks which are called as row hammers, and in fact these can be also demonstrated over a JavaScript and therefore demonstrated over the network. You can actually perform like trashing on the DRAMs, basically access them very fast to create bit flips, which again can be security concerns. It can compromise the key, it can change privileges, and so on. So now the question could be that how can we extend side channel attacks to commodity processors? So this brings us to the topic of what are called as microarchitectural attacks. And in fact, there has been a recent work, or not very recent now, it's called as Spectre and Meltdown, which basically tries to question the whole evolution of computing systems. So it says that when we are designing systems with only performance in mind, there can be security concerns, and fixing them later on can be really costly. So this is something that I believe that when we are even developing AI systems, we need to kind of keep in mind that if we kind of, like first deploy them and then find out the security issues, then fixing them can be pretty late. So design for security should be kind of an important aspect that we probably need to kind of remember. So in particular, when we looked at side channel attacks in the context of cryptographic algorithms, when we target the modern day computing systems, one of the very sort of coveted architectural piece is what is called as the cache memory. So when data is available in the cache, it is quick, and when it is not, it is slow. And people have tried to kind of exploit this and perform even remote timing attacks on cryptographic devices. Now, what is the implication of this on, like there are attacks where people have shown that quite with less effort, you can perform such kind of cache attacks on standard ciphers. But what is more interesting probably is that these kind of class of attacks can also be extended to AI systems. So here is a very quick reminder to that. This is a recent paper that we published at CHESS in 2023, where we showed that when you take a PyTorch implementation of a standard machine learning library, there are like standard transformations which are called as max pool. The way it is implemented, there are like data dependencies. There are like standard if-else statements which can create data dependencies, which can again potentially lead to like a very interesting class of attacks. In particular, you can probably know you can probably launch something which are called as membership inference attacks, and that essentially wholly relies on the fact that the library was developed agnostic of these kind of lessons. So likewise, what about the power footprint of machine learning accelerators? So this is the recent work that we did, and like if you measure energy and power, there are many telemetrics that are available even on NVIDIA chips. You can do that and pretty much read out the internal architectures of your transformer networks. So this work shows like that when you are deploying these kind of machine learning architectures, you have invested a lot and you would like the business to kind of come up out of it, but there could be like malcreants who can just sit on the devices and probably potentially get your IP, and that can be concerning. There could be many other concerns exploiting such kind of things that also can like be discussed upon. What about trusted architectures? So when we talk about trusted architectures, the idea is that there is a secure world and there is a kind of like real world. The idea is that in the secure world, you should be only whitelisted, and only then you should be allowed to perform a critical computation. So this is a work where we try to kind of question ARM's trust zone being deployed on some Raspberry Pi devices, and we try to look at the security authentication mechanism. So usually, right, in Linux, according to Linux convention, when the security check is properly executed, it should return a 0 value. When it is not, it should return a non-zero value. So the experiment that we wanted to do is when the Raspberry Pi board is executing, we try to take our EM gun that I showed you in the video, and I was trying to kind of, we were trying to kind of shoot EM pulses, which would basically zeroize a bus. And then what we observed and what we demonstrated is that you can pretty much, if you're able to do that, you can pretty much whitelist any code, and that would still run in the secure world. And that basically means that you get complete control on the trusted architecture. So here is a very short video to kind of demonstrate that. So you can see here that this is the EM pulse and this is the Raspberry Pi board that we target. So in this particular attack, we use a combination of side channel and fault attacks. In particular, when the verification starts, there is a significant increase in the signal because there is a cryptographic operation that is getting executed, and that immediately shows up in the side channel, like footprint. So we see that, and based upon that, we time our fault injection so that you know exactly when to shoot your EM pulse. So what we want to do now is that imagine a critical infrastructure is running, like a machine learning as a service, you can imagine. And once we enter into the device, into the trusted world, you shut down the service. So you basically do a denial of service when you are not, imagine that if you are doing it for a critical infrastructure, the consequence that it can have. So here are some attempts to perform the fault injection. Of course, like there will be some failed attempts, but then when you are successful, you can pretty much control the device. So here is the train that you are observing in the side channel, from the side channel. And now we are kind of timing your fault injection. So these are the pulses that you are shooting in the purple line that you can observe. This is an amplifier for the EM pulse. And once the fault is successful, the payload in this case is just a shutdown. So you can shut down a critical operation. Yeah, so we jointly with the OPT developers also developed a countermeasure to protect against this attack. But the point remains is, and I will conclude with this, that there are various future directions that probably one can think about. For example, there are multiple trusted architectures that are coming up. For example, Intel has come up with this new Intel TDX architectures. So we had a collaboration with them where we demonstrated that there are still significant amount of side channel leakages that one can observe. In fact, when you are running your machine learning as a service in the trusted world, you can kind of get correlated information which talks about very sensitive information that probably can happen. There was a press release based on that. And likewise, there are also various other interesting directions, like when you talk about cryptographic systems, you need to kind of probably get ready, and India is also getting ready for the post-quantum world. We have our Indian National Quantum Mission. As a part of that, we have one important objective of developing a chip for post-quantum security. And finally, I will conclude with this, that as I mentioned, that India, since we get our hardware components coming up from different zones and different boundaries, the question of trust is a paramount importance. And we are trying to develop, I would say, state-of-the-art facility by kind of looking into the chips. And basically, when I say into the chips, I mean, look at them layer by layer and try to understand that the chip that you get back and the chip that you have sent, they exactly match. For example, this is an image that we have got from the observations. So, and this is the chip design that we have sent to the fab, and we are trying to develop formal verification techniques to essentially perform match between them. Likewise, there are also questions about fake components. And there we use an X-ray microscope to kind of understand that the components are, exactly as was originally supplied by the OEMs. So we believe that our vision forward is, we all know that there are threats. India is not alone. I would say the entire world has got similar kind of concerns. And I think the missing piece is to train and upskill our young people. And that, I think, is of paramount importance. So in this context, we have been, I've been trying to kind of do a lot of developments in Asia. For example, we did chess in Malaysia, and I was one of the program chairs. We are also doing ACM Asia CCS in Bangalore next year. All of you are welcome from 1 to 5 June in 2026. And we also have an Indian conference which we call as SPACE, which we do it annually every year. So with this, I would like to say thank you. I think the missing piece is the hardware. So we need to kind of keep this in mind, because if we do not do it now, then later it might be late. Thank you.
Yeah, we can discuss now.
Thank you. See, we are talking about standards for AI, and we are talking about how to regulate AI, right? Many discussions keep on happening and going on. In the same fashion, hardware, while it's not specific to only artificial intelligence growth, but then it's a factor in a growth for artificial intelligence. Like, are we actually also talking about how to regulate the growth of hardware for artificial intelligence research? It's like AI for hardware, hardware for AI, that kind of thing. Or is it like just like keep on going? Like in the morning we heard that the compute requirement or the energy requirement for these hardware are going up and up, right? So are we going, like, should we think of regulating it? Because AI is going to be resource hungry, just not with respect to data, it also with respect to energy consumption. And one of the major sources for energy consumption here is at hardware level. So are we talking about at international community level, because two of you are expert in that, so are we talking about how we reduce this energy requirement and go to 20 watt? In the morning we heard, right, the brain consumes 20 watt, not half a megawatt, right? So are there efforts happening in that direction where we regulate, like don't go beyond this much power.
The overall, like you have asked a very important question. I think any hardware designer would typically, like to make things low power and, like low energy. But I think it is not, it is probably, both, in the sense that until unless your algorithm is properly designed, right? So it may not be conducive to an extremely low energy or low power, requirement. So I think on this is kind of something that is probably going on around the world. People are trying to come up with low energy by coming up with new devices like post-CMOS techniques, which can really minimize the power consumption. But at the same time, it might be also that there is a missing piece. Like, we usually kind of conceive neural networks or, like other machine learning architectures in a typical manner, but that may not be the most ideal way of doing it, right? So there may be alternative ways of doing that as well. So I think it's both of an algorithmic question as well as an implementation question when you talk about energy and power specifically. I mean, that's my take actually.
Where is like quantum hardware fitting in all these discussions? Because future is there. I mean, we all are now talking about 5 years. We'll see the quantum world. So where is like I'm in Aadhaar Vision 2032 community, and we are already talking about at 2032. What about quantum? So I'm sure the same discussion must be happening in the hardware community also. How the growth has the trajectory for the growth towards quantum would actually move. So, any ideas?
So in my experience and think in general, industry really dislikes regulation because they think with some justification that it will slow down the pace of development. So most of the regulation I've seen that seems to get traction is not constraining what companies do, but requiring they declare what they're doing. So another bit of research I do is on privacy technologies, and one interesting application of that is where companies can show where the amount of energy that their system is using without having to disclose where they're buying energy from and which part of the system the energy is using. But after that is then up to how do you encourage organizations to be more efficient? Well, some of that is just not necessary because energy costs money, and these companies work very, very hard to save energy. But markets do break down at some point. You have externalities. So when those happen, then this information collected on energy usage could be used for subsidies or penalties to address the market failures.
I think just to add to that, I would say, like, when you talk about quantum, right, then probably there are also other concerns like reliability. So you would like to do your computation more reliably. So those are also missing. And I would say that regulations are probably to some extent more important when we talk about security and privacy. But when we talk about these things like energy and reliability, it's more of a technology problem. So we need to have scientific innovation to solve this specifically, in my opinion.
Thank you both for your talks. I was just kind of musing on. Oh, that's yours, is it? Yeah. Okay. In a way, you're. I think one of the things that happens to software over time is that we layer on more containers to kind of make stuff more secure, and then what you're saying is, as we sort of layer on these things, there's more side channel attacks. And I was just kind of musing on, that whenever we want to pay the price for security, it adds overhead, and we won't do it. But then we do end up with these retro fixes, don't we? And then I'm wondering whether one of the roles of AI, when you're talking about training people, is that it sort of reinforces what we currently do in terms of like mining the common patterns. And we're seeing more people building on a code bases that already exist, for example. So what I'm wondering is AI going to work against your ability to make this paradigm shift because it's going to reinforce the way we currently do things, which is not the way you want to see things being done. Is that almost a question?
Yeah, I think that's something we're already seeing, that the programming languages and techniques for which there's a lot of training data generally work better than the ones where there's less training data. So for example, it's much easier to get better Python code than Go code out of LLMs, because there's so much more Python knocking around on GitHub. And that does slow down development. If someone comes up with a really new clever technique or a new clever language, if there's not a large corpus in the LLMs are trained on, it's going to be very hard to convince people to use that. That could conceivably get better as LLMs get better, when they're better at translating something that's learned for one situation, let's say one language, into another one. But until that gets better, yeah, we could be stuck at the particular techniques that we have at the moment.
I think on the topic of security, so your comments. One that you hear a lot about, so you talked about the cost of it will take to convert programs into Rust, for example. And there's a lot of work happening on converting using AI for legacy code. Thoughts on how good or not so good it is? That's one question. Second is, AI is also being used to write unit tests and testing, making testing better, and also potentially to look at security vulnerabilities. What are you seeing role play, good, bad? Is it working, not working?
Yeah, that's a very good point. I almost included that in my slides. There was a large DARPA program on automatically rewriting C into Rust. The results were mixed. So the resulting code worked, but was completely unmaintainable because it was written in nowhere, in a way that was very confusing to anyone reading it. So that was problematic. That could be fixed. That was one experiment. So I think that is a potentially promising technique, but right now, not so feasible. And sorry, the second question?
For using security testing.
Yes. I've already seen students use that, and it's quite a good technique. It's fine for testing functionality, less good for testing security, because you really need quite a devious mind to come up with exploits for security. You need to be thinking how the programmer was thinking and how to trigger the circumstances that will violate those assumptions all at the same time. And that requires a level of creativity that LLMs don't seem to be demonstrating now. But we've seen how fast they evolve.
I think another small piece that I would like to add is that we did one experiment once actually, because when you specify English language, right, there's a lot of ambiguity in the language, and the LLM can be kind of tricked into giving a wrong code actually. So specifically, we try to do that for Verilog, which is basically the entry to the hardware design flow. And you can actually tell, for example, that okay, I want a very secure chip and so on, right? And suddenly, if you talk about reset, it might have a line which just resets and resets your security conditions actually. So it can potentially lead to a lot of vulnerabilities in that context actually. But having said that, people are writing proposals on even LLM-driven chip designs. I know that there are end-to-end, and actually we got one chip which is purely LLM driven actually, at least the RTL translations. But still, I think it's a lot of work has to be done. Specifically, I think formal verification would be an important thing to add on.
Okay. All right. So this is a question for both of you. So when we look at the kinds of hardware security features that have become successful, they're often ones that were easy to implement within the architecture. They had sort of a minimum impact on software, and they sort of didn't really add a performance overhead, right? So when we look at, for example, TEs, it's sort of SGX suffered from a lot of problems because of that. Sort of TDX became more successful. When we look at the capability world, where we have sort of Cherry as a kind of bigger architectural change, then there are things like ARM pack, right, authenticated pointers, that are sort of much simpler, and therefore they actually see sort of production adoption. So I guess if you had to predict sort of how hardware security features are going to evolve in the future, sort of what are we going to see, sort of both to enable a world with capabilities and to protect against side channels?
I would say that based on whatever I've seen, it is extremely difficult to plug out all side channels actually. Like if you say, like that, that's probably $1 million question, that whether I can make a trusted architecture which can, like plug out all side channels. So I think probably the road to go forward is to kind of combine cryptographic techniques like verifiability in particular, and that brings us to this topic of zero knowledge proofs actually, in conjunction with your trusted architectures. So this combination, in my opinion, right, is a very nice direction to go for. Kind of, like have the good points of trusted architectures and the good points of crypto, because crypto will also leak in certain cases, and the TDs will also have its own limitations actually. So to combine in the best possible fashion is something that might be a very interesting direction to go forward. In particular, we were trying a project where we are trying to look at searchable encryption, and we know that searchable encryption also leaks, but then we were plugging the searchable encryption leakages by the TD, and the TD also leaks. We were trying to use the crypto to protect that actually. So that is one direction of approach.
Yeah, you're right that persuading people to use security features is hard. I think there is an argument that there might be a market failure happening. So one result from Microsoft is that the cost of one big memory safety vulnerability to one big customer is more than the cost of implementing Cherry for them. But the reason they're doing that is because there's not the coordination happening between all of Microsoft customers calling for this to happen. And I think that's why governments are interested in this. So Cherry was funded by DARPA initially. Now a lot of the work is being funded by the UKRI. And what they're arguing is that there is a market failure, and if they can push Cherry to the level that it becomes much more easy to transition over to it, then people will do that. And that will overall save money, but the industry would not be able to do it by itself. But in the meantime, there's also a lot of interesting things happening with the lighter changes, like enhanced, is it EME in the new iPhones is massively increases the cost of carrying out attacks, even though it doesn't have the same level of simplicity as Cherry does.
Very good. So we had great discussions, 4 sessions, 4 lectures. Now that we are much wiser, we could go for lunch. And I just had a little observation that we think that low power chips could be made by mimicking the processes of brain, which are highly parallel, low power neurons but working together, analog computing rather than digital signals. And third, that you would have sparse coding, was pointed out, right? So only activate those parts which are really needed for your purpose. But I think it goes beyond that, because you see brain, there are a lot of mysteries there, of course, the kind of computing it does, but it's wet and it's soft. It's not hard and dry like scientists, right? So I think maybe there is a fundamental difference that we don't know yet about what's the difference between wet and soft and dry and hard. But it's much harder to make something which is reproducible when you have architecture of brain, which is why people don't like it, because it's not reproducible, it's diverse. So diversity is a hallmark of nature, which is not the hallmark of industry. No, so you want to repeat, you want to make the same clones of everything. But who knows, maybe the future is all about diversity. Letting loose the power of diversity, and we did not yet there, because then what you cannot control, people don't just hate it, right? Anyhow, let's conclude the session. Thank you very much for very stimulating discussions and presentations. We thank all the speakers. A big hand of applause for them. We break for lunch, and then we have some more exciting discussions here post-lunch.
Shall I start? A word of warning, not a super technical talk. I can't do super technical talks in 30 minutes. And I tend to get carried away. But what I'm trying to do here is lay out some of the problems and a call to action at the end, like, you know, what we could possibly do collectively. Maybe not everybody here, but, you know, in our networks as our parent organizations, as individuals, etc., etc. So I thought I'll start from the very basic because I know I'm preaching to the choir, but it's very good to have a definition, so that I don't get questioned about what I mean by responsible AI, but responsible AI means that and means this. This is what I mean. This is my definition from which I'm working, that it ensures that AI systems are developed and deployed in ways that align with ethical principles and societal values. And that part is actually very important for the work that I do and I kind of advocate. Right? The societal value part is extremely important to me. So what does, when people talk about responsible AI, these are the kind of things that everybody is talking about. Fairness, AI must treat all individuals equitably, accountabilities. Developers don't like it, but developers are responsible for AI outcomes. Transparency is understandable to users. Privacy, and this is the part that everybody understands. Like, this is the most talked about part. And of course, safety, that AI should not cause harm. Now, I have, and I'll just like to take this thing about privacy and go back a little bit to what I said about societal values. I have spent a lot of time in a lot of rooms where people are heatedly debating privacy in terms of data privacy, is our data kept privately, what are the norms here, who is doing this, who is preserving this, who is preserving that. And actually, this is where I would like to bring a sort of a global south / global majority / whatever your favorite term for the region is, perspective into this. Privacy is actually not on the top of the mind for anyone talking about responsible AI in, say, a country like India. Privacy, the way we view privacy is very different from the way privacy is viewed in, say, the US or the UK, right? I'm talking about the nation as a whole. So people can be very private about their low points and high points to the general public, or may not, but within the family, privacy is not important. And my favorite example of this is, two favorite examples. One is like a single mobile phone is shared within an extended family, right? So what are the privacy bounds here then, right? From husband to wife to grandparents to children, everybody shares a single mobile phone with a single number. There are no like multiple identities on it. The second is, when I got married, my mother would walk into our room even if we were sleeping, right? We weren't allowed to shut the door and put the bolt or any such thing. They would have been very offended if we had. So we have to keep these kind of things in mind when we're having these debates and discussions. Of course, privacy is very important, but how does a society view privacy is also important. You have to kind of balance those things out. So again, these are like well-known challenges, but I would just like to talk about them, or at least flash them out up so that we are on the same page. That ethical standards, like I just said about privacy, vary across cultures. The language thing is actually very important, as we heard in the previous sessions. There is a lack of benchmark that covers all languages. So what are you even evaluating stuff on? How can you even say that some AI system is good at this or not good at that? If you don't even have a benchmark for that system, right, in that language. Similarly, because of the limited representation in training data, it's very difficult to ensure fairness and inclusiveness. And this has safety repercussions as well. Because, if you know the literature, then you might be aware that it's very easy to jailbreak using a less represented language in the data, in the model, right? So if you're asking, say, a
GPT, for example, to create some offensive image, right? And you keep asking it in English, and it has like all these guardrails, everything in place, it will refuse. You just go on for hours and it will not create that image, right? Just try reverting it and do it as 3-4 times in Bengali, right? And you will get that image. So a low resource language thing is not just an access or a nice to do or a charity thing, but it is actually essential for the safety of whatever the model produces, right? We talk about embedding these responsible AI principles in the models, and this is about AI development. We should be ethical. There should be principles that we adhere to when we are developing AI, fairness and equitable outcomes, transparency builds trust, and therefore, people believe or are more amenable to the AI decision-making process when we have these automated systems. And also, we should have standards and guidelines in place, which is all very well, but everyone then goes from those principles to creating actual frameworks, and I'm just like putting this as an example. I'm not going to read through this. These are the kind of frameworks that abound. Believe me, in the last 6 months, I have seen at least 18 responsible AI frameworks, from UNESCO all the way till some civil society organization working in one corner in India, right? They are very useful exercises, I think, for the people who produce them, maybe, but there's very little to choose amongst them, and they all talk about these things at a level where, the outcomes are not very clear, in the sense, how do I, as a developer or an application builder or a user, take these frameworks and actually put them into practice? That's not very clear. And I'm telling you, maybe there's one principle different here or there, but almost all these frameworks are pretty much the same. There is no need for 18 frameworks or 20 or even 2. We could do with just one framework and that would be just fine. The other thing that people bother a lot about is safety protocol and governance, and this is slightly more difficult, and I will talk about how it is much more difficult in multilingual and multicultural things, because when you're talking about safety protocols, and maybe Mayank will talk more about this, and governance, it kind of requires some governance guidelines in place. It requires that you have protocols in place. It also requires that one thing that we forget when we get into this debate about regulation heavy and regulation light governance, etc., it requires regulatory capacity. So it's all right for me as a state to say that, we are going to penalize anyone who puts out deep fakes or fake images in this particular context, right? For children's safety, for example. How am I even going to enforce it? Where are the tools that allow me to do it? Where are the people, the whole infrastructure that allows me to do it? So making regulations is easy. Building regulatory capacity is difficult, and the focus on regulatory capacity is much less than debates on what the regulation should be, shouldn't be, who is it going to harm, who is it not going to harm, right? So capacity is clearly missing here. And here again, I will go to one thing that is very popular for when we talk about safety, it's red teaming. Everybody, let's do red teaming. Now, to do red teaming, one thing we forget is that you have to do red teaming in the context in which AI is, used. Now, if I take red teaming protocols or whatever red teaming procedures, red teaming data from Singapore, and just translate it to an Indian language and use it here, what it will show me is that if somebody in Singapore used Hindi to break the system, they won't be very successful, or they will be successful only like this much percentage of time. But it's absolutely useless about what that system can or can't do in this country. So, you know, these are very popular words and notions and concepts, but we never ever think of them in a contextualized manner. Of course, that's a hyperbole here. The never ever is like, there are people. So when we talk about, you know, I'll come back now to the basics, that what we'd actually require before we can even talk about red teaming and regulations and all these kind of things. And we need to talk about data, we need to talk about evaluation, and we need to talk about appropriate applications. And only in that context can we talk about safety and responsible AI, right? At the top level, it's just too generic and it would miss out everything along the entire pipeline if we don't do this. So first, of course, is the language-specific bias. An AI that is focused on one language will be blind to biases that are articulated in another language. And I have a very good example of this. We were doing some study, and we had asked you know, some young girls in tier 2, tier 3 towns, and even in villages, to talk about gender, to come up with gender-biased statements. And one of them came up with a statement in Hindi. I'll first say it in Hindi and then translate. लड़कियों को दांत दिखा के हंसना नहीं चाहिए. Girls should not laugh showing their teeth. Now, does it make sense in, say, the English language or culture? But anyone who knows Hindi immediately understands what that means, and what that actually means is that women should not laugh with abandon, because women who laugh with abandon are certain kind of women, right? So you see how language plays a big role in how these things are articulated. And, you know, this is true for cultural misalignment, and I know, you know, the previous example also goes for cultural misalignment. There are things that are, in English you have like just one U, right? In Hindi and a lot of Indian languages, we have 3 U's based on the kind of respect or the status of the person you're addressing, right? I mean, in the older times, you could say there was a thou as well, but, you know, that's fallen out of practice. But this is very much in practice. That's a cultural norm that we have to respect. Even more than that, think about pronouns. We have had these gendered pronouns put out as if they exist everywhere in the world. They don't. In India, most pronouns are actually neutral. Most languages have neutral pronouns. We only have one pronoun which is the same for whoever you're addressing, right? So when people start getting into these big debates about whether there should be gendered pronouns or not, etc., 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 or judge LLMs and AI systems on the pronouns they produce, they don't make sense in this context at all, right? We have to think differently. Sorry. Yeah. And this brings me to the last bit, which is really important, last bit of this thing. How much time do I have? About 10 minutes. Okay, that's cool then. So, you know, how do we evaluate all these things? How are they aligning to the values of a particular language or culture? And how do we even evaluate those things are problematic. So I will, you know, going back to my translation, you know, basically why I'm against translation is that all the benchmarks right now, all the things that we evaluate, you know, any AI capacity on, for a particular language or a particular culture are just translated from existing benchmarks. Now, if you take a benchmark in English for safety and then translate it into Hindi, Bangla, Tamil, or any other language, and that's not a benchmark. I don't even know what it is. It doesn't make sense, right? And I gave that example of the lemon pie, key lime pie earlier, because this is a real math test, part of a benchmark on a math test bench, that John and Mary have a key lime pie, and they need to divide it into 4 parts, okay? Now, if you translate this into, using any translation system, you translate it into Hindi, you will get John or Mary के पास एक key lime pie है, जिन्हें उन्हें 4 भाग में करना है, which is exactly what was said in English. Now, how many people in this country know what a pie is, leave alone a key lime pie? And the whole solution of that problem is hinged on the fact that there's a round thing, it's a fraction problem. There's a round thing which has to be divided into 4 parts, right? And there is no system which will turn a key lime pie into a roti or a dosa or a puran poli or whatever, right? So that problem is unsolvable even if you translate it using the best machine translation system. So test benches have to come from, and evaluation has to come from, again, from the context. I know I'm sounding like a broken record, context, but that should be my name, really. So just to kind of, emphasize that all is not wrong. I'm not saying we should throw away the established frameworks, but there are strengths, but there are a lot of weaknesses that we have to be aware of, right? And the biggest thing is the threats. Unchecked misalignment in underrepresented languages can really cause a lot of safety issues. I cannot emphasize this strongly enough. So I'll just touch upon this because, I have been part of the drafting committee for the AI governance guidelines for India, which were released earlier this month, that what is the government's view on inclusion and responsible AI? So like Rohini had mentioned earlier, the government actually wants a low regulation scenario. They do not want a lot of regulations to burden the startups and to let, to kind of misconstrue or I don't know, adapt a metaphor from a very different context. This is the time for the government to let 1,000 flowers bloom, right? And therefore, the regulations on what flowers should bloom, where should we cut it, what color we want, what colors we don't want, all these flowers together can make one single flower. That's not like a worrying thing right now. But the thing with the AI governance guidelines is that they are not set in stone. There is a recommendation that every 6 months a technical committee takes a look at it and revises it based on where the technology is at this moment, because the technology is moving really, really, really fast. So you can't have regulations, that never change there. Okay. So that's about the regulations. So I forgot to put the references. They're not showing. So 25% of safety gaps in non-English AI outputs, right? They're 25% more than English, which is not surprising at all, considering that non-English languages include all these various low resource languages. There's something that I have worked on, which is code switching, which we do in multilingual societies all the time. We switch between the 2 languages that we are most comfortable in. If you just stand outside and listen, you will find us switching between English and another language like rapidly all the time, and that can be used to jailbreak as well. If you do not handle code switching, which is how 90% of the Indians speak, you can cause jailbreaks and other safety issues. Now that was for all non-English languages. This is only with Indic prompts versus English, right? Indian language prompts versus English. The 30% more unsafe outcomes. Right? So clearly this is a problem for which we need to build robust multilingual resources. Direct translation is the way a lot of people have gone, which I have already, I think, said enough about. There is synthetic generation that's happening a lot. So the languages that you have low data in, you use the data available as seed data, and then you get LLMs to produce synthetic data. You can use a combination of translation and synthetic to get more robust data outcomes. And if you use these, the model safety metrics actually jump up. Just by like having enough data, they jump up by 15 to 20%, right? Which is great. And there are a lot of efforts in India on the data side of things. So, these are all the examples of various organizations that are putting out Indian language data in pretty vast quantities. So we're trying to build a lot of indigenous data sets to help tackle some of these problems. I will not talk about this in the interest of time, but this is one of the things that we did in my team, where we actually created data in 30 Indian languages, which is culturally nuanced, and it's synthetic, and it is open for everyone. It's available on both AI Kosh and Hugging Face for anybody to use. The last bit is about evaluations. So how you evaluate actually will feed back into how you improve the system, right? And in our context, I think community-driven multilingual benchmarks are extremely important. That allows the voices of the people to be involved in it. It's not like a bunch of researchers sitting in a corner coming up with all possible examples. It is the best way to get culturally relevant data. Right? There is no other way to get culturally relevant data, and it allows real-world language use and a nuanced safety coverage. So it's not a very black and white. However good you are in a particular language, even if you belong to a culture, if you yourself alone are sitting and creating these prompts or these benchmarks, you will not get the nuances. You will not. For me, as a Hindi speaker, when that girl said, girls should not laugh with their teeth showing, it wouldn't have struck me. I understood her immediately, but that wouldn't have been my first go-to example of gender bias, right? So it's extremely important that we do this in a community way. And the way I think is the best way forward, and the way we are also working on it, is by integrating automated and human scoring rubrics. So we have, we take the best of both. We have the humans kind of not only provide the prompts or the benchmark data, but also do the evaluation, which feeds into the LLM as a judge mechanism. And we kind of use a hybrid method going forward, which allows us to do both, so that we don't rely dangerously on any one method. And again, this kind of gets all the local context that I've been talking about. And OpenAI just now has released, I think like 2 weeks back, they have released something very similar. They've released a data bench for Indic languages called Indic Q&I. And what they have done here is that on various topics, they've taken experts to give the data. And also, again, a hybrid of LLMs as well as human experts judging that data. So they've asked Indian, Hindi-speaking doctors to provide the medical data, right? And also to judge the outcome. So they've done something like that. And This is another example called Samiksha, which with organizations like Karya and the Collective Intelligence Project, and we are also, Microsoft Research is also kind of involved in it. And here also the idea is to get the community involved and get the data done in this hybrid manner. And this, is the kind of pipeline we have for Samiksha, where we kind of think about themes in a particular domain by talking to civil society organizations that are working with AI in the field in that domain, like agriculture and healthcare, etc., or with experts. Then we do like a query generation on those topics with community members and non-experts, and then we kind of have a response generation and evaluation by both LLMs and by community experts. So doing this, we've done a couple of pilots and they're very interesting. We've kind of tweaked some of this up, and we plan to, by the time the Impact Summit is here, we plan to kind of release a leaderboard based on Samiksha of all the models that are available and claim to work for Indian languages. So that's what we're planning to do. I was going to probably talk a lot more, but I don't think I have time, and I don't want people to get late. So I just want to kind of talk about this part, and then I end. We really need to mobilize the multilingual AI ecosystem. We have to keep in mind that 50% of this world is bilingual. And that's a huge thing to think about. Like, half the world is bilingual. So clearly, we have to worry about this entire ecosystem. And I think there are a lot of opportunities to do that. Collaboration on safety benchmarks is one thing. One particular organization should not own a benchmark. While OpenAI has put out the Indic Q&A, it's an experiment right now. Like it's a kind of a first step kind of a thing. And if you put out open benchmarks in the open, your models get contaminated. I mean, the benchmarks get contaminated. Your models consume those benchmarks. So then what do? Do you keep putting out benchmarks after benchmarks after benchmarks? Should Microsoft or OpenAI or Google own all the benchmarks and keep putting out numbers and saying, your model did this, our model did that? Who will believe them? So you do need an institution which is neutral, which is perceived as neutral and perceived as not favoring one or the other, to kind of hold these benchmarks and conduct these benchmarking exercises. And that requires a lot of collaboration. So I think that's one way that we could all go out and do this. The second is, I think that, I did talk about the frameworks, but one thing that's missing is we really should think about multilingual AI safety playbook, not frameworks. We're done with frameworks. I am like up to here with frameworks, but we need playbooks with codes, with tools, with codes, pieces of code, with tools, with guidelines, with instructions on how to go about doing something or the other, how to do, where to find the benchmarks, where to find the resources. This would also be something that, as a collaborative effort could really work. This could be something that we could all do collectively. So these are my two calls for action. And I end here. And over to Gopal. slides, please? I don't know.
But we're going backwards, are we?
Let's start with the Q&A.
Be a bit different.
Oh, sorry. I will continue to talk from here. Sorry, Gopal.
Yeah. And
I think it's good
Right, so I was just saying, well, great to be back on this workshop and at IIT Delhi, first time at IIT Delhi to present this work on responsible AI. And 2 years ago, I was just starting my research program called Responsible AI UK. And now we're 2 years in, so I'll give you an update on where we are and what we've achieved, but also touch on some of the challenges, both research and societal challenges that I've seen emerging in the last couple of years. So I'm a professor of AI, by the way, and I run this research program called Responsible AI UK, which is a £33 million program, which started in May 2023. And my background is AI and mainly multi-agent systems, and I'm quite pleased with what's going on right now because we're talking a lot about agents, and I'm getting to talk about stuff I used to do in my PhD. But to start with, and I think a couple of you have already covered a few of my slides, so thank you very much, and you've done that through much more detail than I will. But I'll try and cover quite a few other challenges as well as the ones that you've dealt in. But to start with investments in AI, as Peter mentioned earlier, and lots of money going into AI lately, billions of dollars, of pounds. The UK announced multiple billions of pounds just this morning and yesterday morning. And investments from the US into AI infrastructure. The UK is investing a lot into AI for science, but this pales in comparison with the investments by private individuals like companies like Oracle or individuals like Larry Ellison at Oxford University. Gave £1 billion just to one university. So the question there for me is, can research organizations really compete? Now, what do we do? And when teams at DeepMind, Meta, OpenAI are so big, so huge, and can and have access to much more compute than us, where can we focus our energy? And I think increasingly lots of incremental research being done in the universities. We just cannot compete. We have to do something different. We need to focus on something else, and maybe trying to keep those companies honest in working on responsible AI and working with governments and civil society groups to do something about the responsible adoption of AI is one place we can focus on. But AI moves really, really quickly, and we need to be mindful of the existing challenges that we're trying to deal with, and many of you have talked about those: energy, cultural diversity, cultural insensitivities of LLMs, just one. Trust in AI is becoming a key issue. But the field moves so fast, and you need to be anticipating those challenges as soon as something new comes up. So 2 words have been added to our vocabulary in the last year in AI. Can you guess what these 2 words are? New words that didn't exist before in AI. I'll just give you one. Have you heard of vibe coding? Have you tried vibe coding? Right? How many of us AI experts are using vibe coding? I pushed this to we had a big all-hands meeting for our AI UK last week. Elvira was there. And people have heard about the word, but the research projects that we had funded had not studied the potential issues with vibe coding, where you're giving potentially non-expert users the ability to code, to create apps, test them using just simple prompts, and deploy them using simple prompts without proper validation, without proper verification, without proper expertise in how to validate these systems. It's getting really tricky, and maybe at some point it will work, but what are the implications of this on the quality of software that we push, on the quality of tools that we build for practitioners? The other word that came up is agentic AI. Agentic AI is a new way of talking about agents. Software agents have been around for a while, and if you've heard of agents, you know that they are systems that can act autonomously, plan, and reason. Examples are chatbots, for example. And the problem with chatbots is, as you will have probably experienced, they don't always quite understand what you really want to do, and don't understand when they are getting it wrong, unless you explicitly say, and actually they explicitly ask you, has that solved your problem, right? And then you say, no, give me a human to talk to, and then they say, oh, I'll pass you to the agent then, which is really funny. But anyway. So 3 challenges I'll talk about. One is safety. I think Kalika has gone into this in quite a bit of depth, and evals as well. And so I think the similar problems I'm going to talk about. But on AI safety, that was just 2 weeks ago. AI-powered stuffed animal pulled from market after disturbing interactions with children, obviously not tested and been probably hacked, I would guess, but and not tested in context, and was giving really, really bad advice or bad recommendations. And lots of things that you've heard already around learning from human feedback is very expensive, so you can try and train these systems to be safer, but it's expensive to get people to test them. It's expensive to build benchmarks. I was at a meeting with people from ML Commons who talked about the cost of building benchmarks. I don't know if you're aware of this, but it does cost a lot of money to build a benchmark. They estimated it to be around $5 million if you want to build a good benchmark for some of these systems, for these big LLMs. You want to really, really test them hard. You can prune them, and we've done some work on pruning LLMs and identifying. So most people are trying to prune them to be more energy efficient, but they lose the safety guardrails, so try and prune them in a safe way. That's another bit of work that's going on. Or just more data, just collecting lots more data that will also be very expensive. But you also have the incentive on the other side, right? Along with billions of dollars invested in AI, you also have billions of dollars lost in AI if you get it wrong. When we saw the culturally inappropriate images generated by Gemini, or when DeepSeek came along and showed that you could do things more efficiently, it hits your share price and you lose billions in a few seconds. That sort of testing by the markets is expensive to these companies, but keeps them on their toes. I think that's why you see OpenAI pushing out various new evals, new methods to test their systems, contextual evals, for example, that just came out. So they're very well aware of this. So again, it raises the question of what is the purpose of the research community? What can the research community do that's comparable to this, that gets them to react really, really quickly? Because our way of trying to keep these companies honest is to build these benchmarks, try and build an international organization that is trusted, as Kalika was talking about, and getting everyone to agree. That takes time. It doesn't take seconds like this one. Right, so, and you have 2 million models on Hugging Face. How are you going to benchmark all of these? And I think society and markets are evaluating AI every day, and industry is aware this is responding rapidly. So give them credit for that. So another challenge that's coming up is overtrust. I think 5 years ago, I started another research program called the Trustworthy Autonomous Systems Hub. It was a program that tried to address the issue of trust in AI, robotics, and industry came to us and said, oh, can you make AI that people trust? We didn't have ChatGPT at the time. Now people trust AI more than they should. And recently, my team published a paper on this. People trust legal advice from ChatGPT more than they trust a lawyer. Okay, so I think we solved that problem of trust. We funded a £12 million research program and answered this question in a number of ways, in a number of AI applications, but ChatGPT came along and now we have too much trust. Now, how do we get away from this? That's another big question, right? And another team in our program looked at the answers given by ChatGPT and why you should not do that. Examples include, oh, I don't have it here, but basically it gives bad advice sometimes. It may sound convincing, it may be more understandable than a lawyer, but it may not be appropriate advice. And one thing that just came up from a discussion I had with someone in government, the advice that you get from, or the prompt that you use with ChatGPT to get some legal advice is not covered under client's privilege. So when you talk to your lawyer doesn't need to divulge what you discuss with them. But when you talk to ChatGPT, OpenAI can actually be asked to reveal that prompt and all the information that you've given it. Right, that's so giving a chatbot, giving an LLM client's privilege is not something we've thought about so far, but it is quickly coming up as a big problem. And how do we do that? You know, OpenAI or the agent that we might have may not be a real entity. It doesn't have an identity, so you need to have an identity to be able to give that sort of privilege. So overtrust and client's privilege, some of the issues in that context in particular. Kalika mentioned some evaluation metrics are quite poor, or at least not context specific. So you have all these epoch AI, and just to bring that point a bit more to the fore, this is what they write on the website: trusted by leaders at OpenAI, DeepMind, and governments worldwide. That's their claim. It's trusted by everyone, except the public. It doesn't mention the public on there. It doesn't mention which public. And it's all commissioned by OpenAI. It claims to be an independent benchmark, but commissioned by OpenAI. Now Gemini 3 is beating everyone at it. You can see at the top here, Gemini Pro preview is performing better than, I think, GPT, and by a small margin, but beating Sonnet 4.5 by quite a bit. And then you have Center for AI Safety that published this Humanity's Last Exam. Have you heard of this Humanity's Last Exam? Do you know what it's made up of? It's a global effort, nearly 1,000 expert contributors affiliated with 500 institutions across 50 countries, comprised mostly of professors, researchers, and graduate degree holders. They are the ones who put the questions to create these exams, which businesses, like business leaders, use these to determine whether these tools are appropriate or not. Are these meaningful benchmarks? There's a big question. There are big questions around the validity of these benchmarks in terms of their potential societal impact and safety that they actually believe that they create. At Responsible AI UK, we have 3 projects looking at these sorts of evaluations in different contexts. One is very technical, led by Professor Mariella Kata at Queen Mary University, a project called AdSolve, looking at LLMs in the context of mental health support, so chatbots for mental health, and also in legal settings. The FORM project is led from Glasgow by Simon Stumpf and is looking at auditing benchmarks. So when you're using these tools and you want to audit them, to audit their use, involving the end users in the auditing process is what they're working on. And Probable Futures project is looking at the use of these tools in law enforcement and helping law enforcement agencies evaluate them with appropriate guidelines or tools. You can find out more about these projects on our website. Emerging challenges. So these are sort of known challenges, and you already have projects that are looking at those, and we've been talking about them. So there are a couple of interesting new challenges emerging now with the kind of words I put on the screen earlier. Well, I didn't put that one. Research integrity. Huge challenge. I'll give you a couple of things to just bring that, make that really, really palpable. Okay. So if you heard about a conference called NeurIPS, maybe? Technical people in the room, China's submitting the NeurIPS, we've heard that story. AAAI is happening in Singapore. AAAI is another big AI conference, and received lots of submissions. Nearly 30,000 submissions this year. Last year was about 10,000 or 8,000. This year, 30,000. They had to recruit 28,000 reviewers, poor guys. Out of 30,000, 20,000 were from China, potentially because of the Singaporean attraction, because papers could not be submitted to NeurIPS. And 75,000 authors. So to manage this, they had to use they used AI to detect papers that had been AI sort of generated in some ways. Basically, some authors submitted multiple papers with minor changes to them and architected with AI. The program committee used AI reviewers, an AI reviewer agent, but didn't actually use it to decide on the final outcome. They're testing this tool right now. It's not perfect. It's clearly not perfect. And that number of papers, I mean, it starts raising questions though. Is it okay to use Grammarly to fix your grammar? Is it okay to use ChatGPT to survey the web? Or is it better to use Google search? What would we accept as a community? Should we use AI to generate papers? There's an AI scientist a tool that has been produced that helps you write papers using AI. But this paper that just came out at ACL, best paper at ACL, which is one of the top AI conferences, or linguistics conferences, is from Gupta and Pruthi, actually, a paper from IISc Bangalore. Showed that many of these AI-generated papers are plagiarizing other papers. So you think you got a great idea, a great new idea, but it's actually copied it from someone else, and you just add a little bit to it. And then you have big investments in AI for science, like in the UK, just announced last week. Huge investments, and there's significant concerns around the use of AI in other scientific applications, not in science subjects, so not just in AI itself, AI research. And there are risky uses of AI, and I've already pointed to some of them. So LLM-based synthetic data generation. So people are using LLMs to generate questions for other AIs and test them. We've heard some examples of that. Ambient AI to record human conversations. So you're collecting lots of data about patient conversations, for example, in a healthcare setup or in mental health applications, so you use this ambient AI. Is it perfect? Probably not. If you're using ambient AI in many qualitative studies, you would not get reliable outputs. AI to analyze real data, and we've seen this with CERN. CERN's probably world leader in using some of these tools. James Webb Telescope probably generate lots of data. We'll be using AI to analyze images from those telescope, satellite data as well. We need to be sure that these tools work perfectly so that we can rely on the results to meaningfully analyze and then define whether something is working or not. Literature reviews. A number of researchers are using them to just summarize literature. I'll write my paper, and I'll just ask it to generate the literature that matches my paper. I've heard my postdocs do that. we had a little chat about that. Ideation, right? Can you generate a new idea using AI? I think you can, right? You can say, okay, take concepts from this field and let's apply it to that field. It will give you some initial ideas. It will not be perfect, obviously. And very hard maths is very hard for AI still. But there are many other things that we should identify as potential risky uses of AI, and we're not, as research communities, we're not really working hard on defining, on writing down the guidelines to use AI. What is it that we regard as a good use of AI in research, and what is it that we would not like? What tools should we give the researchers to prove that they're using AI reliably? Otherwise, we can't do a proper review process at the other end as well. So research integrity is going to be a huge issue going forward. So yeah, how do we train researchers to use AI responsibly? How much time do I have? 5 minutes? Yeah. How do we make sure humans understand humans versus machine contributions, and how do we translate these to other sciences? Then we have agentic AI, and I talked about evaluating LLMs and generative AI systems, but you have now not just workflows of LLMs, you have agents that can try and understand what's happening in the environment. This is Anthropic's definition of an agent. But just to let you know, there's been the notion of agent since 1994, and a much richer definition of agents. We talk about autonomy, proactiveness, social ability, reactivity, etc., etc. These concepts still hold in the new age of agents. The new age of agents just tells you that you can do this more naturally, in natural language. But how do we evaluate these agents? There's a whole workshop series run by NIST at the moment that's trying to understand that. How do we ensure they conform to norms? What new attack surfaces are we creating with these new agents? Huge issues for cybersecurity. And how do we team them up with humans? And I've done a lot of work on, and share the paper, to show you how we design systems of humans and machines in very complex systems like disaster response systems. At the time, we didn't have LLMs, but the same learnings from these sorts of systems still hold. And architecting them such that humans feel in control, or machines can be given more autonomy to undertake certain tasks in low-risk settings, and how do we verify human or track human and machine outputs become a serious problem as you scale up the number of agents and humans that work together. So provenance becomes a major issue. And the final challenge is AI economics, which don't talk about much, and computer scientists talking about economics is not very common. But recently we did some work with the Gates Foundation to understand how we move from sort of small pilot systems to scale up across continents, certain deployments, and issues of sovereignty arise. What dependencies you create when you, for example, let USAID fund your data centers in Palo Alto, as it happened in Kenya. And Kenya lost all its electronic health records because it didn't have them in country and was not funding it itself. So how do you fund these things? And what other dependencies you have on other infrastructure like mobile telecoms, and how do we finance these tools? So some of the learnings from the work with Gates is this. One is the pilot syndrome. Many donors in many developing countries just get stuck at the level of building pilots, and they can never actually scale up. They never quite understand the unique costs of these systems. Who takes over after the donors? So you build this small pilot, you demonstrate it works in a small village in Kerala, in Kenya, and then you can't scale it up because you have all these issues come up in terms of who gets the benefits, how do you measure benefits, how do you coordinate across multiple sectors, et cetera, et cetera. So these are some of the technical challenges. I'm not sure I'm going to have time to go through societal challenges. I'm going to skip those and just mention a couple of things. This is what RAI UK's role is in the UK, and lots of things and lots of milestones. I can tell you more. We have a whole annual report that just came out. I will share that in due course if people are interested. But just one last thing I wanted to mention is the work that we did following the last Yusuf Hamied workshop here. I met Professor Ravindran 2 years ago at the workshop, and we decided to run a sandpit just outside Delhi at Nimrana Fort. And we followed that up last year with that workshop. We brought 15 researchers from the UK. Elvira was one of the mentors on that program, 15 researchers from all the IITs. And we co-created 2 projects. Not going to talk about that. Lots of international initiatives. One project looks at edge AI, so building AI at the edge, and one's looking at technical regulatory sandboxes. The technical regulatory sandboxes is actually with IIT Madras and a team at King's College London, and trying to test new AI systems, and also design regulations for new AI systems in tandem. And that's also with IIT Bombay. The other one is off-grid AI with IIT Madras, Swansea University, and Nottingham, and is looking at building VPR, so visual place recognition applications in the context of PFOL, damage caused to fields in Kerala. And really pushing to the edge, expensive, computational expensive visual place recognition algorithms. And working with the local communities, not to impose technology on them, but to work with existing applications that they use. For example, one of the things that they use is a WhatsApp interface. They just use WhatsApp for everything. So they can interact with this VPR system to map the environment, to report where peacocks have been damaging their crops, and do that via WhatsApp. And the agent replies to them. So we don't change their work practices. So I'll just close on this. I don't want to take too much time. I'll just leave this slide. Thank you.
Thank you very much. Two very different discussions, covering some very timely topics, very Do you want people to speak with the microphone? Yeah. I think it's the capture.
So I have a question related to your presentation. So have you come across the concept of normalized global brain? Which, well, I'm pretty sure you can imagine what it means, and it reflects. So once we have a lack of diversity, and specifically language, and you've described so well how language carries not only, well, culture, values. So if we rely too much on a specific language, the new generations somehow absorb the values of that specific culture, and we end up with a world that where we are not yet, so it becomes a normalized global brain. So I just wanted to just curious to see if you came across that concept.
When you explain it, I've come across that concept, like, you know, how, and there are a lot of people who are writing about this and worrying about this, and how, you know, a lot of the younger people relying so much on generative AI for writing or creating, etc. Everybody is getting squeezed into this one way of expressing themselves. Just one way of expressing themselves. So, and we've seen this over ages, not for generative AI, but only on the language side. You know, how as people come into cities, so if you were in Bangalore, you would discover that even though Bangalore is a very cosmopolitan city, with people coming from various parts of the country, when they've stayed there long enough, their children only speak English, right? Because that's the common language amongst everybody there. And you have to make special effort to ensure that your kids speak their mother tongue, or the, you know, whichever tongue they identify with. Yeah.
And very quick, so Gopal, just wondering, so if we look back in history, we had many types of very disruptive technology, from the calculator, TV, etc. So, and humans, we are very good at making the same mistakes over and over. So do you have any insights from previous research, I don't know, media studies or more cultural, tech and cultural, so there's something we can learn?
So one of the things we knew already, for example, I mean, from some of the research that was done on human-machine teaming when it comes to AI, the results still hold. People tend to believe that these AI systems have better capabilities than they actually have. They overestimate their features. We had a washing machine control agent that supposedly turned on the washing machine. That was built in 2011. Could turn on a washing machine when the wind was blowing and the energy was greener, and people really thought that the AI was predicting that. We just simulated the whole thing and in the study, but they really thought that was doing that. Plus, the agent was detecting when they were at home to turn it on. They believe certain things, and that sort of insight translate very well across to to GPT and others, we need to be really worried about this, because what we are not really conscious of, and we've been conscious of that in some of the studies we've done, of when I mentioned the disaster response system that we built. It basically instructed humans or teams of humans to undertake tasks in a disaster zone. So that was before LLM. So the agent would say, go and do task 1 at this location. And the human had only one option because it could not communicate with the agent. The option was no or yes. Right? There's no maybe. And every time they press yes, the team gets formed. If they press no, a new team has to be calculated, everything gets cancelled, everything changes, and they push the system to a local minimum. To fix this, we added a human in the loop. So we added a mediator human to get the machine to understand what the humans want to do. So humans were able to express their intent, so express why they were not doing things, how they were going to do things. And that allowed the mediator to tell the machine what is going on, and that resulted in much better outputs. In a sense, GPT and others do a similar thing. So they can understand your intent because you're conversing in natural language. And that poses for me a bigger risk. When you do a search on Google or any other search engine, you don't express intent, you just put keywords. But when you write to ChatGPT, you say, not feeling too good today, give me some things to do for the rest of the day. Or, my girlfriend's left me, what can I do in my life now? Or, you know, I've got these things on my skin, it looks like this, I take a picture, upload it, what do you think it is? Oh, go and take this medication, right? What you're actually telling GPT is what you want to do or what you're feeling right now. And therefore, GPT and others are learning our behaviors, our intent, better than any other search engine has been able to in the past. And their answers can then be manipulated, if someone wanted one day, to induce certain behaviors on us, right? And that could not be done in such a sophisticated way before. And that's my big worry, is that we now have better control, better understanding and better control of the users of those systems than we ever had before. And that opens up a lot of potential risk around manipulation.
Yeah, that's a good question. I'll start over here, really. I think who's responsible? I think this is one of the interesting questions, right? These things are a function of scale, aren't we? We saw earlier in the talks that the more data, the better these things become. Economically, it's better for NVIDIA and all these guys to do things at scale. But the bit that's not scaling is how this plays out in the context around the world. And that's very expensive for them to do. And it's not like a medicine where we give them the burden of proof. You have to demonstrate its efficacy before you put it out in the world. It's the opposite, actually. The costs are felt somewhere else. So actually, you know, is it actually impossible to build responsible AI? Because we can't verify that it's safe, and would we be better off building lots of smaller, more contextually relevant AIs that at a scale we can actually make responsible?
No, I don't think that, you know, having a completely safe anything is not possible, right? You can never have. Yeah, exactly. But I do think that in some sense, I think of it as different people are responsible at different points in the pipeline. So absolutely the model builders are responsible for the data that they kind of train the models on, but they can't be 100% sure of the data. Like it isn't a foolproof thing, right? But then people who are developing on top of the models also have to be aware that this is not foolproof. So what kind of things can we bring in at that level? Then people who are doing applications have to be aware, and they have to bring in certain things. The governments have to, along with the civil society, have to come up with things to make this safer. So I think of this, this is a silly analogy, but again, you know, a lot of analogies in AI are to cars for some reason. Everybody go back to cars. But you know, there is an engine that's being developed, right? And the engine makers are responsible for a certain level of performance of the engine. But then there are car manufacturers who take the engine and build the cars around it. The users are responsible because they have to use the car responsibly and according to the rules, but then somebody has to come up with the rules for driving as well. So I think there has to be like a multi-stakeholder.
Yeah, if I can also respond to that. I think, so I've been trying to build a couple of AI companies myself in the last years, and very often things didn't work out because people asked, so how can you prove it will save me money? So we tried to build green hydrogen systems. People said, okay, so how much will that cost? And what's the benefit of AI in there? You don't quite see the AI in there. Or we're optimizing grid systems, and people say, so will that save energy by save us 15% or 20%? What? And we said we can't until we do the trial, until we run it for a long enough period. No one's asking that question to the hyperscalers. OpenAI is spending 100 billion and making only 13 billion, right? People are making huge bets on this stuff. What worries me is that governments are starting to make these bets. Like UK government is betting, I think, saying it's invested 2 billion in the research in the R&D, and is commissioning 150 billion dollars or pounds of investments into joint investments, and we're still seeing some struggles with investors actually putting in money. So that's one problem with governments is, do they actually understand the ROI on this investment? And it is even much harder for governments in low and middle income countries to really figure that out for themselves, given first they lack the skills base capacity. You know, would they better invest in AI education or basic education, rather than buying huge data centers for billions of dollars? Right, in the UK, our education has been poorly funded for so many years. Should we put 150 billion in education rather than AI? Would we do better? Right?
I'd say yes.
So why is that not happening, right? Why is that not debate informed by understandings of AI ROI? First, no one's doing the research properly on the research on return on investment on AI. The only group that we've worked with and was funded by RAI is the Productive Institute at Cambridge University, Professor Diane Coyle. But even then, they have limited access to data and applications of AI. But it's also the case that, as I mentioned in my talk, we as researchers in the field of computer science AI need to keep abreast with the tech. Otherwise, and it's been very vocal in the UK. I mean, people rocking up at meetings with the Prime Minister, not quite understanding what an LLM is, right? In the early days of LLMs. You can't go and talk to a policymaker without understanding the tech that you're talking about, right? The tech is moving so fast. So what's the benefit of vibe coding to sector X, right? So, no, that's just if you just say it's just a fad, you lose that crowd, because the way they are going to be lobbied by the tech companies is going to be much more professional, much more slick than we would as academics. So we need to up our game as researchers, as academics, to really present the risks in an understandable way and demonstrate with evidence to the policymakers. But the biggest challenge is stay relevant to the conversation. We can't afford to just sit back. You know, we funded a UKR program 2 years ago. Just sit back and do the research we commissioned 2 years ago. Right? No, we have to adapt, listen to what's going on, watch what's going on, and use it and comment on it. And that's what we're trying to do at RAI. We watch what's going on. We spin up these big convenings to get people together and write up a policy note of some sort. And that's really hard.
So what I took partly from that was a sort of risk literacy piece about, you know, because I think I've seen that. I've seen decision makers say we really need the people making these decisions in government to have better literacy on what AI really is. So if we drop the I, actually, because there's no intelligence in there, that would be a good starting point. Yeah, that's cool. I like this idea about taking responsibility for the products, but there's something kind of interesting there about being able to afford to take part. And I mean, UK in many ways has much less money than NVIDIA and these big tech providers, so those partnerships are really supporting them. And if we think about that rolling out globally, can you participate at that scale, and is that a good thing to do? And I think we saw the talk this morning about the sort of digital infrastructure that is sort of minimally insufficient for a really large-scale deployment, and I think bringing some of those questions in would be good. I've got a new term for you: vibe research. That's what writing the papers with AI, which have no value to society at all. Vibe research. You heard it here first.
Thanks for the talks, both. I had a question about the evaluation piece, where I totally agree with you that if you're developing a chatbot of sorts, especially for, let's say, farmers or healthcare workers, you want the prompts or the questions that they would ask, your evaluation benchmark should reflect the prompts that they would actually ask, right? Now, one of the challenges that we've faced while deploying these chatbots is our initial versions of the models are so brittle. They don't want to use those models and provide you the data that you would require to build your evaluation system to make your model better, which would then have them have value gained from it. So it feels like a chicken and egg problem. Yeah, how do you solve this?
So, I mean, don't deploy models that are so brittle, because it is true. Like we tried to do, we were doing this evaluation thing where we thought it was very easy. It was going to be like, we'll take these English prompts, we'll translate them, and we'll give them to people to evaluate, rank them in some way or the other, right? This was like a couple of years ago we did this, maybe 2 years ago. We translated everything, gave them to the workers, and they were like, this is nonsense, we don't even, this doesn't make sense. Half of these translated, and this was just English and Hindi, which is supposed to be a solved translation problem, right? And they just were like, we can't do it. We don't know what you're asking us to do. How do we rank this in terms of bias if we don't even know what you're talking about? So then in the end, we fell back on workshops and templates. We couldn't use the actual technology outputs at all till the technology was at a point where you could deploy it.
So how do you get real data
So
to?
so I'll tell you, we actually, it's the slow, tedious, expensive process. The only way we expedited it was by giving them templates of some sort to fill. Or the old times where you gave them scenarios and then asked them questions about.
So yeah, I think the answer is exactly that. I think that's what we've come to realize with all these hyperscalers are doing. How did they get GitHub Copilot to work? Hundreds of programmers writing code to train it. How are they getting Claude to write novels or novel level type text or legal text? Employ lots of lawyers, employ lots of writers, write the text, train it. It's super expensive, that's what I'm saying. Some of these benchmarks are expensive, and one of the slides I didn't get to show was around what's that causing to the job market. So for many applications, many jobs, you don't need an intern to come and do it anymore, because GPT will do it. Like, write a marketing email, give me a picture of something funny, right, a meme or whatnot. You can do that with Sora, you can do that with GPT, Claude. The stats, the latest numbers from Indeed.com show that I think 30% of entry-level jobs have disappeared from the platform. So you see that effect, and I think if you're going to hire 100 lawyers, train the tool to do all these legal text, and then fire all of them, how many lawyers will then lose their jobs? I think insurance is the next one, because lots of insurance documents and underwriting is done in a very standardized way. So lots of people will lose their jobs, but it's expensive, and not many people can afford it. I think we should profit from that time where all these VCs are investing in these companies to afford that training. Once that money goes, I don't think they will be able to do that anymore unless you can demonstrate ROI.
Thanks.
Any other questions? If you don't count one more question.
So we've been speaking about regulation, and I have a question to both of you of sort of what is the right way how we should be thinking about the future of regulation in the space? Because when you see what is happening in the world, there's obviously sort of the US that is sort of pushing ahead in terms of innovation and like just, well, doing new things, really putting regulation on the back burner. The same is happening in parts of Asia, where there's sort of a big emphasis on innovation and not so much regulation. Europe sort of tried to differentiate itself by sort of thinking about the regulation piece seriously, but now sort of it seems that a lot of those efforts are running out of steam, and there's sort of significant pushback, and it also becomes obvious that you can't really regulate if you don't have significant buy-in. So what is your prediction how this space will evolve?
Regulation is hard, takes time. In the UK, we're trying to go sector by sector. In the EU, decided to use standards and decided to classify systems as high risk, low risk, medium risk. And then recently they issued a consultation on what's the high risk system. They realized they got it wrong. So regulation, I don't think is going to make this work anytime soon. It's going to take a long time to actually work. What I think we can do, and we're going to try and do some of this with the work that NIST is doing with CMU, is to come up with standards and not wait for the ISO and the BSIs and Sensenelec to come up with their own standards, is to actually demonstrate how you should evaluate these systems with sort of data sets and maybe creating organizations that help do that in a trusted way, and write up those guidelines, write up these standards in whatever sectors we think are most critical, like healthcare, and publish them. And companies will sign up to those and say, okay, well, this is driven by respectable organizations, and then the ISOs and the others will follow because it takes too long for them to come up with these things. I think we should take the lead on that. I think that's what the research community should be doing. It's not trying to, training your postdoc in LLMs anymore. We need to try and address the issue from the other side and build up benchmarks. That's one way of doing it, at least.
Yeah, so I think in India, tried to balance things a bit. We've gone sectorial. We plan to go sectoral. So each sector will have its own kind of risk tiers. Regulation-wise, it's felt right now. The government reserves the right to change its mind anytime. But it's felt right now that there isn't a need for new regulations per se, and the laws that are applicable to AI as well, and they can, if they're enforced, a lot of things get covered in that, and wherever there is a regulatory gap, that can be examined at a later point. But I actually agree that we need credible bodies like, maybe made of researchers or something like an IEEE or other such organizations coming together to set the standards, because no one knows what the standards are here. What is required of a company as well. And if once those standards come into being, people will kind of sign up. I mean, companies always sign up to standards. They love standards because that's an easy way for them to do things, right? The other thing when you say about like this, difference between EU and how, look at Switzerland. Switzerland signed up to the EU Act, but they interpreted it completely differently. So they went a little, slow on the more restrictive things, right? Similarly in India, Bangalore has the highest density of startups in the world, followed by London. Did you know that? I just learned that last week. And the government doesn't want to curtail in India, but we also have extremely vulnerable populations in this country. So you don't want to kind of, adversely affect them. So it's a very difficult balancing game.
Well, I'm going to now close the session. Thank you so much to our speakers, and then we've had this very rich discussion afterwards. So can I thank you everyone for your contributions to this And I will now close the session.
Taken? So it's already Gen AI. So yeah, there is a term called Gen AI, which is an acronym for generative AI. I know. So maybe it means who knows? In 5 years, we may have Gen AI sitting over here. So yeah. Maybe robots talking and robots listening. That's Gen AI.
Double the number of slides, but it will mean that we will hopefully have enough time for the conversation. So can I speak?
Thank you. So, while I know once I have an hour to speak, I'll try to not speak for an hour. So, but since morning, my job has become very easy. So I started actually making the slide since last night. I did not know what Rohini is going to talk. So I created something, but then I saw Rohini's talk. I had to edit, right? And then Kalka talked a bit. I had to again edit. So since morning, I've been editing my slide deck, and hopefully this is in a shape where I can communicate, probably summarize the whole day's talk together. And this is where so when I moved back to India, I was involved in Aadhaar project, India's national biometric project, way back in 2009. And I contributed in doing the very first proof of concept, that is Aadhaar possible in India, and then went on writing the standards, which even till today Aadhaar is using. I was part of all the evaluation committees, like whatever has happened in Aadhaar in the early days of setting up. I was involved in almost all the deliberation and committees. And so over the years, I have learned a lot from what Aadhaar looks like today. And again, fortunately, I'm in the Aadhaar Vision 2032 committee, like what is Aadhaar 3.0 and 4.0. So now we are setting up the roadmap for another 15 years for Aadhaar. And I honestly believe that when people were not talking about artificial intelligence, we were already talking about artificial intelligence, but the name was biometrics. Right? And Aadhaar is one of the, as you also mentioned this morning, that Aadhaar is nothing but a very big national ID project, which is essentially an AI project. So there is a lot to learn from Aadhaar that actually we can look at what we can do in the future, or what we can do currently with generative AI being one of the most prominent forces. Right? So this is kind of a mix of what Sam Altman has said, what mix of what all of you have said since morning, and what I believe is like in connection. And I'm going to draw in my different slide decks, I'm going to draw analogy as well, that what Aadhaar has done and how we can do this in artificial intelligence. So models are becoming very powerful. In fact, I copied a particular prompt and then gave it to Midjourney, and Midjourney created a very realistic video. Right? And so it's a detailed prompt, which actually talks about a person where in the background you see Eiffel Tower. So I said, okay, let me actually change the prompt. It may be like just because the prompts are so Western, probably that's why the outputs are good. Why not just change the prompt a bit? So I created 2 more videos. One with changing the prompt to only like Red Fort in India, in Delhi. So I started seeing like some of the glimpses and elements of Red Fort over here, like particularly Delhi. And in the second prompt, I said I changed it to Jodhpur, from where actually I come from, and we are like we are proud to have a very beautiful fort. So if some of you happen to be in India for a long time, I would love to host you in Jodhpur, and then you can go around and see the culture as well as the beautiful monuments. And I just changed the attire also from a dress to a sari. And Midjourney did a fantastic job, even mimicking that. So while I understand Kalka's concern about culture, but these models are becoming and behaving like and becoming powerful in terms of starting to understand the culture. In fact, just 2 days ago, while yes, once I see her face, but but see, just a couple of days ago, Meta has launched their ASR model, which is with respect to 1,600 languages. So that's what the claim is. Okay, it can understand 1,600 different languages and dialects, which is actually means I still have to test it, but that's a claim, right? So again, like means maybe in 6 months down the line, we may see much more powerful, more and more powerful things coming up, and obviously all the major companies are competing with each other on this. However, since my talk is mostly going to focus on the AI governance, I'll be actually focusing on the governance side of artificial intelligence, and certainly I'll not be talking about the Oppenheimer lessons with respect to how we should just completely close everything in artificial intelligence. By the way, means again, I have borrowed this particular idea, AI EA for AI. How many of you know who's actually first time came up with this term, AI EA for AI? It's Sam Altman. Yes, last year he proposed that AI EA for AI should actually happen. And interestingly, UK supported the idea. And then Prime Minister actually supported the idea that yes, this is a good idea and we should do it. I personally believe it may not be a very good idea, but yes, means let's talk about it, and maybe towards the end of the presentation we'll have more questions. But I'm here to actually mostly, again, as I said, going to talk about how we can learn from Aadhaar, and if we really need to bring something like that, then what should be that particular structure. But before that, I'll also, like, given that I've worked a lot on deepfakes these days, I would also like give a note of caution that there is still a governance gap. And this is like a big talk, at least in India. In the last almost 2 years now, we have seen a surge of deepfakes coming in, multilingual deepfakes coming in, and it has impacted many sectors, right? Including the most recent Operation Sindoor. Also, we have seen a huge amount of influx coming in for deepfakes. right? And even industries are also getting tricked, as people are getting tricked to, and then the cost of this particular attack is very high, right? And just to actually make sure that everyone is not sleepy, I have actually a Turing test to all of you. So that's a bad habit. Like being a professor, I always ask questions in the class. So, so this Turing test is that I'm going to run 2 music videos, songs, Hindi songs. So even if you don't understand the song, that's fine. Don't understand the lyrics. But can you still, just by listening, can you figure out which one is real and which one is fake? This was sound number 1, and now this is sound number 2. This is exactly same song, same lyrics, even same music as well, 2 different singers. 2 is fake, okay. Who else? 1 is fake. 1 is fake, okay. So first is fake, both are fake, okay. So let me tell that both are fake. The fake is not the answer. One of them is real, one of them is fake, right? So some vote for 1 and some vote for 2, right? Actually, sound number 1 is AI generated in the voice of Atif Aslam, a fantastic singer, but not from this country. Another is the original song, another fantastic singer, Arijit Singh, from this country, who actually sung in the movie. So behind these 2 images, I have actually the videos embedded, at least on sound 2, I have actual embedded video, which is from the movie. Right. So this simply tells that means for our human ears, it may be very hard to discern what is real and what is not real, right? So earlier we have this particular term like seeing is believing, right? Can we today really say that seeing is believing? Now, why did I pick deepfake example for this particular talk? Government in India has been trying for the last 2 years now to come up with a regulation, a guideline, or whatever we call it, to curtail this particular problem. First time last year, they actually launched it, and within a week, they retracted it. Because companies gave a pushback, no, this is not possible, you are going to curtail the innovation. If you do this, then innovation will be curtailed. This year again, they have actually launched for a public interest, and even I myself have actually submitted an 11-page submission that this regulation is wrong, that if you are going to do this. And I submitted to Minister's office that this regulation is completely wrong, this is not the right way to do it. And this is all like around the deepfake only, right? Like, or I would say creative media. So this has both the sides, like even if and there is an app, I don't know how many of you are aware of, there is an app called as suno.ai, where you have to write prompts, right, in English, and you can create the song in the mood that you want, right? Just not the lyrics, the entire song, like a 5-minute song you can actually create. And I would say that's creative part. They have a legal issue also going on, that's a separate problem, but at least it's a creative approach of coming up with an application which can help people like me who can't sing. Right now I can sing as well. So this is where like means at least our discussions at different sectors are happening, and we have a huge learning actually coming from even, in fact this is what this morning Rohini was talking about the India Stack, right? So we have a huge learning from India Stack, or now currently we call it a DPI, where we have stacked multiple facilities or multiple layer of infrastructure together, and view this as not a only one application or software code. We view this as an entire stack of infrastructure, and we govern this infrastructure rather than governing individual components. right? And that's a beauty of this particular approach, which started with the, while like India Stack or DPI started with the creation of Aadhaar in 2009, where actually we learned that we should be worried about the consent, privacy, and the usage, and the application, auditability, everything that we have talked since morning, and we can still achieve and touch the lives of 1.4 billion population, right? And that too with ease. Today, Aadhaar is, no one actually asks for any other identity card than Aadhaar card, right? And most importantly, Aadhaar is not just a card, right? Aadhaar is much more than a card. So I'm going to talk about these 4 components, what foundations, governance, standards, and interoperability. We have already discussed some of them, but then for the sake of completeness, I'll also cover them. So the first part is a foundation. What are the lessons that we have learned from DPI? As I mentioned, so this whole digital infrastructure is just not the a particular Aadhaar card. Like it's not a plastic card that we get, or in US SSN, which is not even a plastic card. It's just a piece of paper, right? It's your identity that can get you connected with all the facilities you get. Be it a gas connection, be it your bank account, be it whatever you can think of, even getting an airline ticket. Right? So everything gets connected, and it has 4 basic principles. The very first is presence-less layer. What does this mean? Means you don't need to be present to prove that who you are. Right? You just have to ensure that you can present your biometric information that can digitally make sure that this is who you are. It means ascertain your identity. You don't need, means another one is a paperless layer. If I have to go and open a bank account, today I don't need to actually submit any papers. If I have to go and do my KYC, know your customer in bank, I don't need any papers to submit. I can go digitally, prove my identity through my Aadhaar, through OTP, and then I'll be done to say that yes, I'm alive. Like my parents have to go and do their life certificate every year in November, and they don't need to go to their home branch in Lucknow while we are still in Jodhpur. They don't have to do any of those things. Online, they can do it, right? So many of these things have enabled because of having an Aadhaar or a DPI structure. Paperless, cashless layer, which you have already talked in the morning. UPI is another fantastic example. We don't need to actually have cash in the pocket. Means I have those 2,000 rupees in my pocket for the last 2 years. I don't pay in cash anymore, right? No one actually even expects me to actually pay in cash anymore. Right? So that is, and then obviously the topmost is the consent layer. Means I am giving my consent, so the power is with me to actually exercise whether I want to use the service or not use the service based on this entire structure, right? So this is very important, right? This kind of structure is very important to understand how an AI system like biometrics, Aadhaar, UPI, everything has all the stacks associated with that, which can actually touch the lives of 1.4 billion population, right? So DPI, again, actually when we all were involved in discussing the whole stack, it actually works with 3 primary structures. One is open standards. So it simply avoids the vendor lock-in. We spent at least 3 months to figure out, like in Aadhaar, how should we avoid vendor lock-in? And this morning you were talking about a vendor lock-in scenario like with NVIDIA, right? So we have now issue that if you don't use a GPU provided by NVIDIA, and if you start using GPU from AMD, then actually we have a huge problem. Because we are trying out AMD's GPU, a computationally very fantastic GPU. Means it has much more RAM, memory, whatever VRAM and the compute, the CUDA cores and everything, and the performance is probably better than H200. Right, at least in our experiments. But because their stack is software stack is not complete yet, we are still struggling with respect to should we switch to AMD or should we stay with NVIDIA, and that kind of vendor lock-in was discussed in 2009 that we should not be only going with company A and then block every other company. So Open API actually, or an open standards protocol, helped us to ensure that there can be multiple players. And we can also enable Make in India program. And that point of time, there was no term called as Make in India, but it was still envisioned that probably something more Indian companies would come and start building this sensors and the systems if we have this kind of open standards. Interoperability, right? Means from let's say banks to even disbursement of different rations and all those things, it has to be interoperable and it has to be smooth. This whole transaction should be as smooth as possible, right? And that's where like we talked about whether from bank A to bank B, even later on the usage happened that now you can transfer a mobile phone number from one entity, from one service provider to another service provider by just like providing Aadhaar here, Aadhaar there, and your numbers will be solved. So it has become like, it has enabled these kinds of services which earlier these services were not even actually, you could not even think about it, yes, this such a thing is possible, right? So interoperability is one of the key factors, and minimalistic. You don't need a lot of standards, you don't need jargons, you don't need like everything just to like kill the entire innovation. So Aadhaar never actually did go into the depth of talking about that standardize even the code level or the hardware level or anything. They simply standardize at the top level, right? Do this, everything else will follow, right? And that will not kill the innovation. And that's what the beauty of, that was the actually design principle that is actually getting successful. In fact, many countries are now following and learning from these DPI design principles, right? And we also had a huge problem with Aadhaar was deduplication at scale, right? India is a huge country, like we all have seen since morning, right? The examples that at least I give, because I'm in the state of Rajasthan right now, that's where I'm doing my job. The state of Rajasthan is bigger than many countries, right? It's the biggest state in India, area-wise, and it is actually many countries can, like at least 15-20 countries can come in within that size, and many countries are much smaller than that. Many times I see the map and say, Rajasthan is much bigger than this country, like I visited recently, right? So this kind of like feeling always comes in. And so this actually gives us a lot of diversity. And when we talked about biometrics, we saw the diversity, huge diversity, from north part of India to west part, south part, and the kind of diversity we saw, deduplication was huge, a challenge. What about frauds, right? What if I keep my right hand and my wife keeps left hand, right? Can we get two biometric numbers? These were the questions actually happened in 2009, 2010 when we launched Aadhaar. People tried. So one person's giving right hand, another person giving left hand, one person was giving right eye, another one giving left eye, and then we were rejecting those at the back end. So how to even come up with the standards, the policies, the learning experiences from these kinds of mistakes that probably, or the frauds that can happen, or the mistakes that actually the system can do, right? So over the years we build a trust in the system. If you get an Aadhaar card today in India, right, authenticated Aadhaar card, if you have an Aadhaar number and it is like authenticated by Aadhaar registry, you can safely say that this is your identity, no one else's identity. That's a trust that has been built in the last 15 years on this particular entity, right? So that is again like something analogous that we should think of in an AI domain. And obviously means we have shifted from just doing authentication, like always proving who you are, versus authorization, that are you authorized to use a particular service. Similarly, a similar analogous can be drawn in artificial intelligence as we go along, and we'll see like how I'm going to draw this particular. So is this the person to, can this person open an account? So change the question, mechanism still remains the same. And as I said, now we are looking forward for what is next future, or Aadhaar 3.0 and Aadhaar 4.0 future is going to be with respect to intelligent authentication, and that's where we are looking at more and more artificial intelligence connections. Right now, means the AI that is going on in Aadhaar was built in 2010, 2011 time frame. Now we are seeing like, okay, with 2025 going on, like how we can use all of these current technologies and quantum resilience and global standards. Now we are focusing on how Aadhaar can go global, where every other country can actually share their biometric template so that it can be very seamless and smooth. E-passports are essentially coming out of that particular mechanism only. So the bridge to the AI over here is, we can now actually discussing, today we are discussing about the institutions to govern intelligence from like learning from our how to govern identity. Right? So that is what my takeaway is. with respect to the bridge to the AI over here. So second part that I'm going to focus on is the governance part, where we need to define the trust by design, right? We have heard this particular term many times, that what do we mean by trust by design? Like, means the system should not be, the design should not be an afterthought. Right? It should be at the time of designing the system itself, designing the governance model itself. And again, biometrics has actually taught us there as well. Like, you can any day actually do a Aadhaar auth log check, like how many times you have accessed a particular service. Right? It's up to, actually you can go on the Aadhaar website, put your number, and you can check how many authentication has happened based on against your biometric information. This kind of providing the power in your hands, can we actually provide this kind of power in the user's hand? Right? So that's where the defining principle is. Similarly, judiciary role is going to be also, when we talk about governance, we can't forget judiciary role, because no matter what we do, the moment for artificial intelligence, the very first step is data. Who owns the data? Right? Who is the rightful owner of the data? We all know about this New York Times and OpenAI lawsuit, which is still going on, right? Means while no one has won yet, but the discussion is still, deliberation is still going on, and the court is already taking note of it. And this is a problem probably very unique to artificial intelligence, but because the models that we have currently, many a times they go with a rote learning approach, where they just remember all the information, and many times they produce exactly verbatim as it is. Like that was the OpenAI case. And while everyone knows about this, there is another interesting work in the vision community, in the computer vision community, which has highlighted that a stable diffusion model, again a deep generative model, was generating almost identical outputs from the data set on which it was trained on. So using Line 5 data set, these were the images, and it would actually regenerate those samples when you're actually providing the prompts. So it was almost like very like identical images that it was generating as if it is like a new image. Right? So these are like essentially the AI parallels for judiciary role. It is still evolving. We don't have an answer about judiciary role. The key question also that actually we should also always ask is that, I think Kalika also mentioned, if AI goes wrong, who is responsible? What to do? Like in biometrics, I know that if my father does not get his fingerprint authenticated, I can go and do iris authentication done. Right? If fingerprint doesn't work for him because of old age, he can always go for an iris authentication. Now we have a face authentication also enabled, so he can always go for face authentication. Right? There are alternate means to a certain extent. What is that counterpart in artificial intelligence? If a system does not give you home loan, right, using an automated script, what happens? So that kind of mechanism of the remedies should also be inbuilt in by design principles, not by as a afterthought. Obviously, means this is a slide which I added after Kalika's talk. So benchmarking is very important, and by the way, I missed that originally, but then when I saw her talk, I thought this is very important. Again, from biometrics perspective, this was very important. The first POC was about benchmarking if biometric is possible for the national scale level or not. Right? So we did at that point of time, we did a evaluation of 3.6 million population to say that yes, 3.6 million fingerprint authentication can happen with a 99% accuracy. So probably with 1.2 billion population, at that point of time India's population was 1.2 billion, we said with 1.2 billion, yes, can happen with 95% confidence. Right? And that's how we went about, like, yes, we can implement something similar. A benchmarking approach has to happen. We need to measure intelligence. We are not measuring right now intelligence, right? But there has to be some mechanism, a benchmark that can measure the intelligence, just not only safety, just not only whether it is multilingual or not. It's not only one question only, right? It is so we give actually a question for a human intelligence. We always like measure in IQ. What is that equivalence in artificial intelligence? Right? At least the way at least I see is we need to have a safety score, right? Rather than only the IQ score, a safety score that yes, the artificial intelligence is going to do this particular job for this particular sector, and this is the safety score or the AI safety score. right? So this kind of benchmarking needs to be also evolved, and it has to be a standardized, means it should be uniformly applicable to all the industries across globe. Should not be like India has A and someone has B. It has to be kind of a global approach. Third, obviously, means I'm a big proponent of having some standards, some minimal standards for sure. At least in artificial intelligence, I believe in having a minimal standards. I believe industry loves it. Academics also love it. And the standard should be designed such that it should not kill the adventure of innovation. At the same time, it should not actually hurt broader communities because of the harm that it can do. So therefore, I think this is what the India AI Safety Institute recently did. It proposed a tiered approach that you can have. So, but it was not standards; it's only guidelines. Kalika can correct me if I'm wrong, but these are not standards; it's only guidelines saying that these are only the broad understanding. Companies may or may not follow, right? But my understanding is that we can, and based on the documents that are available, that we can go in a tiered fashion. That the high risk projects should actually go with the most stringent mechanisms. The medium or the limited risk should actually go with very lenient mechanisms. And most of the applications would actually fall under limited or minimal list, which can be like, which will have very minimal impact if something goes wrong. Obviously, we need to have the safeguards or the rails available, but it should not actually that we should curtail. But certainly for the biometrics in school kind of applications where it is not necessary, that means you put a camera in front of a bathroom, right, in front of a restroom. Don't put that. That is not applicable. That should not be done, right? No matter what you do. So these kinds of like unacceptable or high risk. So there you have certain more stringent rules, whereas for limited minimal ones, you can be more lenient. Right? But the key question actually, at least I have listed one particular question, that should governance focus on foundation model layers or the application layer? And in my understanding, this is where like again Aadhaar learning is. Aadhaar never actually restricted at the foundation level. Aadhaar only talked about what it can control, only yes and no, right? After that, it did not stop anyone for any application, right? Court said that you can't use it for law enforcement application. Otherwise, you can use for any civilian application. No one is stopping you. So that enabled a lot of innovation that came in after the enablement of Aadhaar authentications. So something similar, if we can think of something similar, that if we only focus at the top layer, control the top layer better, so that after that all the innovations can happen. I think that is one model that we should think of as we go along. Obviously, in my recent paper in Nature Machine Intelligence, I talked about the model cards and data sheets, that it is important that whosoever creates a new model or comes up with a new model should actually label what is the training data source, what are the biases and limitations, the intended use case, potential misuse vectors, right? So you should label so that we know that, okay, this if you are releasing a data set, this data set be used for only this, not for something else. If you are releasing a model, then the model should be actually applicable in these scenarios, not anywhere else, right? I was telling during the coffee break, I was saying that, you know, I recently went to a doctor, my doctor, for a monthly visit for my medicines, my blood pressure medicines, and the doctor was actually checking ChatGPT, saying that let me check whether I'm giving the right medicine or not. I said, you are a very senior doctor, you can't do this. You don't scare me, right? ChatGPT is not a doctor. Right? You may be using MedGamma, and then I can be still happy with that because it's a much more specialized foundation model than a ChatGPT, which is a very generic foundation model, right? So that is where like means just label the model so that users can understand that model should be used for what purposes. Provenance, again, like going back to my deepfake example, where if we are generating a new content for applications like entertainment industry or creating a new song which is not harming anyone, just label it that this model has been generated. Like these days, Sora is actually generating a lot of funny videos, which are like with dog flipping around and so on and so forth. People are playing with dogs and all. That's fine. That's not harmful. But the moment Sora started generating samples which are hurting the sentiments of people, that is not fine. Right? So if you label it, that would actually help. That it is generated by AI, that would help to actually do the provenance. And the next bit is interoperability. Again, as I said, like Aadhaar has taught us the API economy, the API mechanism, so that anyone can actually use this open API and plug it in their system, and it can work smoothly. So why not actually we do something similar in artificial intelligence? And this is what all actually can frame in with respect to the proliferation of artificial intelligence. And in India, actually, we did something very interesting with Niti Aayog last year, that Niti Aayog came up with this data empowerment and protection architecture, a broad understanding, and actually not last year, maybe 2.5 years ago. And where the problem was that data stays in silos. Actually, two of the problems were there. So data stays in silo, and who owns the data, we don't know, right? Why not actually just make the data, the owner of the data be the user himself or herself, right? So the solution was that my data, my price, my choice. That was the solution, the DEPA solution. And using that DEPA solution, we came up with DigiYatra. Many of my Indian friends would be already using DigiYatra. It's now a smooth process. Like you go to any airport, in 5 minutes you have already crossed the security check. Right? So that has become so smooth, and this is like in US it is a Clear version. Clear has that kind of approach where like you give your face. You don't have to even show your passport or even your boarding pass, anything. You just show your face and you keep on moving. Right? So we did that particular project with Airport Authority of India, and we came up with this whole architecture that why not have the power with the user that your biometrics stays on your phone. So no one is actually owning any user's data over there. Airport Authority of India does not own any data. User has the biometric data on their phone. You go, you just say that, hey, you know, I'm at the airport. You give your face and you move on. And as soon as you're out of the airport, next airport, your data is expunged. So that's the beauty of this kind of architecture, or this kind of approach that can be actually used. And I believe that future AI agents actually can do this much more easier way than anything else. Similarly, on the same lines, DEPA again had this clause, or in fact, our DPDP Act has also, and your European Union Act also has this GDPR, that you should have the right to get your data be expunged. Right? So if you have given your data anywhere and you want the data to be removed, the right should rest with you. But how do I remove the data from the model? Right? So model already knows that now your data, if your model has been trained on your data, how do I remove that? Right? So that is where, again, the technological innovations are coming in, where we are actually, we are calling it as a machine unlearning problem. Like, can we unlearn the information that you have given, and now you want that data to be removed? So it's not only removal at the data level, removal at the model level also, from the model knowledge level. And just to give an example, this is our CVPR paper. If we have to, let's say, forget golf ball, I should be forgetting golf ball, but I should not be forgetting a tennis ball or a soccer ball or a ping pong ball. Right? It should not happen that forget Mayank Vats, but also forget Ashutosh Sharma. Right? Mayank Vats has asked to be removed, right? But it should, but the system should not forget others. So that is the fine-grained machine unlearning problem. And that is like an interesting path that technological innovations can actually bring in if the whole ecosystem, the governance ecosystem, is not stringent. And in India, we love this term, inclusion by design, right? So a farmer in India, at any place, can actually access any services that government provides, or for that matter, any private player provides. Right? And these days, voice is becoming the talk of the day. Like, this is what in the morning we also heard, that based on your accent, your language, can you get all the information, and that's where multilingual voice information or voice processing is coming, at least in this particular country, in a big way. Right? And obviously this actually brings in more challenges, but I honestly believe that a governance, a broader governance framework and the interoperability could actually help us to overcome this particular part. And the final, like before I close, I have 5 minutes, right? Or 2 minutes? 2, yeah. So this is my last slide, okay. So essentially this is a toolkit, means again this is a word that we Indians love, particularly if the election time. So this is a toolkit, right? And we should be, do not govern the code. And that's what I honestly believe. Let's not govern the code because we can't. Many of the times we can't even understand the code because the codes are generated nowadays. These are only prompts these days. And IBM now launching, already launched their they're called it generative computing. So you don't have to code anything. You have to only think of and then type a few words, and then it will start generating code. Right? So we can't really govern it per se, but we can think of sectoral regulations, governance by design. And just like in CVPRs and conferences like CVPRs and ICLRs, we have someone actually where you can go and cry that PC chairs have rejected the paper wrongfully. Right? So ombudsmen actually are there who can like listen to you that something wrong has happened. Something similar, some similar mechanism should happen. By the way, Aadhaar also has a grievance officer. Right? Every district has a grievance officer. Something similar actually can be built by design, that grievance officer in different institutions, organizations that can actually help the users as well as this organization to come up with better mechanisms. Right? Right to explanation is just like a user's right. Right? This is what even different government agencies have also done it. Standards and interoperability, I have already spoken a lot at length. So combined, the whole thing actually should be treated as a package as we go along with respect to the government's toolkit. So answer is not about IEA for AI or DPI for AI. It is actually the global guardrails plus local rails. That is how we should think of as we move forward. There are certain open questions. I don't have answer to those questions, and I'm going to end with these 3 open questions to all of you. Who gets to govern AI? Honestly, I don't know, right? Govern it? I seriously doubt it. How does governance keep pace of artificial intelligence? Right? That's the second question. Honestly, I don't have an answer because Gemini launched Gemini 3, like Google launched Gemini 3 days ago, and then a day ago, ChatGPT launched 5.1, and today Claude launched Opus 4.5. Right? So the pace is way too fast. And what is the AI equivalence of IAEA enforcement? We don't know honestly, but there has to be some like mechanism, a governance body, which I believe is the global guardrails and local rails. So with these 3 questions, I would end. Thank you very much.
Right, we're open for questions, comments, thoughts.
Yeah, you are audible to me.
This risk-based assessment of AI models is something that I had not particular fondness for, because one thing that gets classified as low risk right now can become high risk by evening and unacceptable by the night. And it just relies on the discretion of the bureaucrat who's defining the risk category. It's just too much power in an untrained hand. What are your thoughts on that?
No, I agree that the clarity should be there with respect to like what is acceptable and what is not acceptable. There are like both pros and cons of risk-based assessment or risk-based guardrails or risk-based guidelines. What I personally believe is that there has to be some understanding of what should be the, at least we are clear about like what is a minimal risk. That much is kind of clear, right? Beyond that, then when the moment we start grading them, this is like level 1, level 2, level 3, that's where actually the boundaries actually keep on getting blurred. So at least we should think of 2 broad categories, if not 3, that one is like we know that this is completely harmless, like creating a song which is copyright free and all the check marks are done, minimal risk, that is one issue, right? Or spam filter. Even if you get like 5 spam mails, doesn't matter. For something which is like false rejection rate and false acceptance rate, you can balance it, you can control it. But the moment actually you start moving into grading different applications with respect to the risk, then you are right, then it's in the hands of bureaucrats. Another approach could be it's community driven. You can think of like creating a community driven approach for grading the risk. Different communities may have different grades for different applications, and you can go in as local as possible there, but then it's more complex than actually it may sound. That like state of Rajasthan has a different level of risk factors or levels, and state of Karnataka has something else. That can happen, but again, that's like we have just distributed the problem to more local hands.
I have a question, thought. You were talking about this IAEA idea, which a few people have been talking about, but can we really have something like this when there's no agreement on what the sort of right framework to use out of 1,000? There's 1,000 frameworks at the OECD, for example, and only about 10 or 50 of these toolkits have been used, apparently. And how can we compare AI with nuclear power when very soon you'll be vibe coding your next LLM in your bedroom rather than using a centralized service like OpenAI or Claude? Now, everyone has access to this technology. We don't regulate software engineering, like software, code in your house, you do things in your house, you can run, and soon you'll be running all these sophisticated AI on your desktop or phone, hopefully. Is there any point in trying to build an enforcement mechanism, or, as we were talking about earlier, focus on standards?
Yeah, so I'm actually not advocating to regulate artificial intelligence in any ways. In fact, my whole pitch is that learn from Aadhaar, build a mechanism, and as I said, like this is like IAA for AI or DPI for AI may not be the right answer. It can be something like you can have maybe a global entity which governs all the major pointers, so that when we are let's say passing a message, right? So or across different communities, that is a global benchmark. But then in local communities, it is then the local or local countries can have their own within that framework their own actually mechanisms. Like ISO comes with standards. In fact, ISO has software standards, right? And many actually companies very proudly write that means that they are ISO certified. Right? So it's not that means we have not tried to regulate software coding also. We have done that unsuccessfully.
That's not regulation, that's standards.
That's standards, yes. But then many government agencies actually say that, do you have ISO standards or not? If you don't have it, will not actually accept the software. So these kinds of things have happened. The people have tried. Successful, unsuccessful, let's not go into that debate. But for AI, there has to be something. It may not be the nuclear power kind of, but that's what I started with. I don't agree with that. There has to be a nuclear power equivalent entity, because the whole discussion started last year about global AI governance when Sam Altman said that let's actually have such an entity, and then Prime Minister of UK said that yes, that's a good idea. Right? That's how the whole discussion started, and then people actually push back. No, this is not a good idea. And in India, we have started talking about DPI for AI, which is also kind of my pitch. But then there has to be a balance between what global community can do and what local communities can do. It is not either or solution. It has to be kind of a collaborative solution across different countries. And you are absolutely right. We don't agree with what is the actual definition of artificial intelligence, or even for that matter, agents. Right? Within India, we have 18 standards and reports written right now, not standards, the reports written on what is artificial intelligence and guidelines. But at some point of time, we need to talk about it. If we don't do that, then we may see like more harm that is on our way than actually at least that's my personal opinion. I honestly believe the Aadhaar did a fantastic job in touching the lives of 1.4 billion population.
Question, because you said biometrics and other, AI has got similarities, right? So in biometrics, right, if I understand correctly, there is a database and you are trying to match with that basically, right? On the other hand, in AI, you do inference, right? So in AI, I'm sorry actually for the voice. So there are some fragilities that also are there in terms of like adversarial injections and so on. So how do you kind of, or what is your position on that? Because AI can be also made to fool. On the contrary, right, biometrics, you do a match depending upon a noise basically.
Okay. So 2009, the very first attempt on fooling a biometric system was an adversarial attack. When we were not even calling it as adversarial attack, that attack has already happened in a biometric system.
But do you think that the potent of the adversary attack on a biometric system and the potent of attack on an adversary attack on an AI system are of similar?
Yes, yes. In fact, again, like CMU Satya's lab, their adversarial printed eyeglasses were for attacking face recognition system, right? And that too in 2014 in their SNP paper, right? So in fact, many of these adversarial attack research started from attacking a biometric system first. 1999, the first paper on 13 points of attack on a biometric system was proposed, much before even when we were talking about attacking a computer system, right? So adversarial attack means, at least what I understand correctly, the adversarial, in true sense, the adversarial attacking in an adversarial way for a large scale system started with biometrics only. Because it was very easy to actually show that yes, I can attack a system like this.
Intuitively, I understand that there is a potent, because you can always, whenever there is a defense, you try to kind of play within the boundary basically. But I'm just wondering that the easiness in which you can kind of crumble an ML model, right?
So same way. We have shown in our III 2018 paper that I can fool a face recognition system just by embedding one pixel. I'm embedding one particular pixel, I can fool the whole system. Biometric system, yes. So at least that was actually my Swan Jayanti proposal also.
And how do you counter that?
So again, in a biometric fashion only, like or in the adversarial fashion only. First simplest is like simply pass it through a low pass filter, right? And then you pass through a face recognition system.
And finally, how much more robust accuracy you get there?
So currently, at least in our lab, which has the state of art on adversarial robustness, we are able to like recover up to 90%.
So that's what I'm saying. Like in biometric systems, you can recover. But when you talk about like machine learning techniques, right, because of results, because of Carlini, Wagner, and so on.
Oh, that we have already 100%. We have already done. For computer vision applications, we have already done that.
I'm saying that there the robust accuracy is pretty low, right?
No. So we have done, as you can look at some of our papers, we have already done like 98-99% recovery. We have already done it. So that adversarial defense mechanism has already matured a lot, and at least all my papers were on both biometrics and computer vision.
And CNNs.
Yeah, CNNs, transformers. Nowadays we are working on LLMs. Like.
So say that this can add par with the normal.
Yes. So means I personally I draw analogy in both the words. Like I'm biometric researcher by design, by study, and now computer vision researcher by area. So we do the parallels in both. Yeah. I think Ronnie, you had a question.
Yeah, we can take one more question.
This very interesting presentation. I was just wondering about the analogy example of nuclear energy regulator. See, what happens is nuclear plants are very few, and there are only half a dozen companies that deal in nuclear plant, and you can go visit them. So it could be actual, the scale is much lower. Here you got, millions of codes floating around. So only way you can regulate them is by having an AI regulator. The example of nuclear energy is not really applicable here.
I completely agree. That's what my pitch has been also.
That's been your pitch. I've been sleeping.
Yes. Sam Altman started this whole discussion that it has to be analogous to nuclear energy.
No, it cannot be, because it's totally different.
I completely agree.
Right?
I completely agree. We can't regulate the way we have regulated nuclear energy.
No, it has
because uranium is very limited.
What do you call it? Agentic AI?
These days, yes, agentic AI.
Is a regulator? Yeah.
No. So we are not calling it as agentic AI as a regulator. No, because then you need another agent to regulate it, and there's a never-ending process.
No, okay, you can trust somebody. Right, okay.
And that's my question, right? Who gets to govern AI, right? Governments? Again, I'm not
it's
sure.
AI that has to govern AI, naturally.
Oh, then we
I'm
are
saying
then we are
agentic
seeing Terminator Genesis movie. I don't know if you've seen that or not. So
no, I'm not talking about movie. I'm saying realistically, because you got billions of codes floating around there. Manually you cannot do it, that regulation, right?
Yeah.
So you have to create an AI that would regulate. With the human wisdom.
Right, right. There has to be human in the loop, yes.
Okay, on that note, human in the loop, human in control, we can maybe end the session. Thank you again for our speaker and all the discussions, and everybody for their contributions today. Thank you.
Load you are putting on the human to say, okay, solve problem, human in the loop.
And we've got some real maniacs in the
Yeah, too many people. Okay, the way you solve it, human in the loop. How?
So what we want to do is avoid the wrong people.
Not just the wrong, it's a cognitive putting on the human to say, decide.
So I think we shouldn't have a system where we say it's the consumer who decides whether they can trust this thing.
Yeah. That's actually my question.
Guys, there is no more food here now.
Oh. Okay, thanks for clarifying that.
Yeah.